Arana. I have been working in technology for more than 15 years and in mobile for more than 10 years. I have been training people in different technologies for 8 years now. I am passionate about two things, my code and my food. And for some reason, I always mix them together. I feel it's easier to learn things when you relate it to food. Everyone eats and everyone knows some kind of cooking. So when I try to teach, I try to make sure all my examples are based on food. For example, a recipe is a class, and whatever you cook using that recipe is an object. Let's start this journey of learning Swift 4 using some delicious recipes and make it easy to pick up. And from there, let's go build some amazing applications for both mobile and Mac desktops. We will start this course with basic components of Swift, which will help you pick any other programming language in future, and then move into more advanced section. This course is built for everyone, from a starter to programming to an advanced programmer who can learn more about Swift if he has prior programming knowledge in other languages. So what are we waiting for? Let's get started with Swift. If you have already enrolled, I hope you like the course. I love comments, and if you are yet to enroll, please enjoy my preview videos. Prerequisites. You do not need anything special to pick up this course. I will be going over from scratch, so people with zero programming knowledge to experts can pick up Swift pretty quickly. Even though knowledge of using a computer is required, so you can watch these videos, and also a little bit of cooking experience will help you to ace this course, since all my examples are based on cooking. But seriously, all you need is a Mac computer and access to internet. So what are we waiting for? Let's start cooking and coding in Swift 4. Tools for programming in Swift. You need a lot of tools for cooking, but before the pots and pans, first you need is a kitchen, where all the cooking happens. Similarly, for programming, you need a place, and that place is called the IDE, or Integrated Development Environment. For Swift, it's Xcode, and Xcode is available only on Mac. You cannot use Windows for development. There might be some hacks here and there, but I would recommend using Mac because that's where it works much smoother. This is the place where a lot of people give up, but don't worry, it's like moving from a dorm room kitchen to your own independent kitchen. So I'm not comparing anything. Everything is much cleaner and easier to navigate in Mac. Once you go Mac, you never go back. So, like your smartphone, even Mac has a Mac App Store. We will head over there and search for Xcode and start installing. So I'm going to search for App Store. When I get over there, go to the topmost corner, search for Xcode, and I have already Xcode installed, so it will ask me to open, but you can open Xcode here and you'll see a get option or download option. You can click on that and then download Xcode from here. The latest version, it's 9.2 while I'm recording this, but it might be updated version for you, or maybe same. So once you have it download, let's open Xcode. You can search for Xcode. So here, Xcode is open and you see a bunch of options. What we are interested in this course is Playgrounds alone, which will be our main pot we will use to cook. So let's get started. Introduction to Playgrounds. So since Playground is something that we'll be using throughout the course, let's get ourselves introduced to Playgrounds, of how it looks like, how to use it, where do we code, how does it even work, and what it looks like. So let's go back to our Xcode that we downloaded before, and here you have a bunch of options. I'm going to say get started with the playground. When you say that, it opens up an option for you where it shows you what do you want to work on this playground for, iOS, tvOS, or macOS. They all have same applications inside them. You can select a blank, a game, a map, and a single view. Since all these are out of our options, the only thing that we'll work on throughout this course is a blank canvas, where we'll start and then we'll start programming through a blank project. I can go here and I can say next, and save the file somewhere. You can always go ahead and then create your projects for these playgrounds and see how it looks like, but I would say recommend start with blank and then get yourself familiar and then go into these extra options. So I'm going to start with blank. I'm going to keep the name same, my playground. Go in here and you'll see that it has something already here. Now we are not going to work with UIKit or variables. We have not learned those, so we're going to look at them later. So I'm going to start with complete scratch. So this is the area where you will actually code something. I can give you a very simple function, the built-in function print. When I say print and give brackets, it will let me print anything that I want, literally anything that I want. And if you see it, it's just displayed. It will display it right below here as soon as it's done thinking, and there you go, anything that I want. So that's an idea of playground. It has different options on the top. If you see here, you have this option here which will show me the standard editor. You can also go and look at assistant editor, which will show 2 files. Now in this case we don't have that, so we'll never see this in our course. And the last one is the version editor. If you have a local version and something on the Git, if you not familiar with Git or version control, that's fine, you don't have to know for this particular course. So we'll be using standard editor for most of this course. Also, we have 3 more options where you can see the navigator on the left of all the different files that are available. If you have more than one playground, if you have group playgrounds, you can see that over there. There's a debug area here, which we had it open by default, where it prints out or does whatever command we give here. If you say print, it will print it here. So this is the debug area where you can see how it works. And on the right side, we have the utilities, where it will have a bunch of different existing classes or objects and things that will be more helpful for you when you're doing more application work. But this kind of gives you more of the utility about the identity of this particular file that you're working with. So that's it. So it's pretty straightforward, easy. Apple made it so that you can actually improve your skills on the playground, and then when you start writing applications, it's much more easier to use bigger application frameworks and work throughout Xcode. So that's how playgrounds look like, and that's what we'll be using throughout. Just try this out and then see if you're familiar, you get to this particular point. Exercise files. All the exercise files for this particular course and whatever code that I'm writing during the course will be available right in my GitHub. So you can go to this link here, and they are also attached in part of the code on part of our tutorial in the curriculum. So you can just go to the library and find all the files. If you can't, you can just always come here to my GitHub page and search for Swift 4 programming certification. Inside this, I have all the different sections available. Whatever code we write there will be available here inside my GitHub. What is Swift? Swift is a compiled programming language developed by Apple Incorporated for iOS, macOS, watchOS, tvOS, and Linux. So it helps you develop applications for all Apple products and Linux. Pretty cool, right? It's very easy to pick up Swift and very easy to master. If you have experience with any programming language, it will be a piece of cake. And if not, it might be a piece of muffin. Just kidding. It will be little difficult to start, but I will help you out there with using this course. So let's look at a little bit of history of Swift. I don't want to go too much in detail of it, but just an introduction. So as per history of Swift goes, it's been changing and evolving year after year. First introduced in 2014 as Swift 1.0 and soon updated later that year to 1.1. 2015 we got Swift 1.2 and a brand new version of 2.0. That same year, Apple announced that it will make Swift open source and released version 2.2 as open source. 2016 we got Swift 3.0 and with some new features, and 2017 4.0 was released. I don't want to go over all the updated copies since no one is interested in the past, but let's look at the current version in this particular tutorial series. We will only focus on 4.0 and make sure we master it. Online documentation and help. Swift has grown tremendously and all the credit goes to the iOS devices. People have been making thousands of dollars to millions of dollars by submitting mobile applications to App Store. Let's do a trivia. What do you think? How much does the top app today makes in a day only on iPhone platform, only in United States? I said top app today makes in a day only on iPhone platform and only in United States. Yes, just a day. Take a guess. Yes, you're right. It's a 7-digit figure almost. It's 6-digit today, but yesterday it was over $1 million. So, and the day is not over yet. So even if your app is in the top 100, you make decent amount of money. I can show you here. So if you say iPhone United States March 2nd per day basis, if you see the top 100 or top 122, there's this app which made $15,000. So not bad, right? Now that I have your focus, the only hurdle that you come across is where to start. You're at the right place. I have a detailed list of tutorials here. Without any history and geography, we will only learn Swift, and we will learn only enough to pick it up and build iOS applications. I have other tutorials that will also teach you how to make detailed application, but this is a good starting point for now. Also, if you get stuck somewhere and can't find a solution, we have Apple documentation. You can always go to Xcode and click on Help, Developer Documentation, and you have all the documentation that you would ever need right over here. You can search for anything that you are stuck with. Let's say if it's UIKit, you get all the information, how to do it, what to do it, every information right here. If it can be as simple as looking into strings, and you'll get all the information about strings. So that's one option. And if you're like me and don't like to see the detailed documentation, there's always Stack Overflow. I'm very sure you're familiar with Stack Overflow. If you're in the programming world, this is something that you'll never miss, where you can ask a question and millions of people in the community will help you out. There you go. There's Stack Overflow. You can ask a question. If I search for, let's say, Swift questions, you can just learn from these questions a bunch of different things. You can look at featured, you can look at frequent, you can look at how many votes a particular one got. So this one, Swift performance sorting arrays. So how to make sorting arrays much better. It's fun. If you want to try something interesting, there's also GitHub, where you will find a lot of open source projects to play with. So it's a good starting point to look at some projects that other people have built. You can search for something like, let's say, Angry Birds. And then inside here, you can specify which language, Swift. There's 31 different repositories that match my search, and you can find a lot of different code. You can look at that code, download it, and play with it. So these are some of the online documentation and help features that are available online for you to start working with Swift. Data type division in Swift. There are two data types in Swift. First, value types, where each data instance keeps a unique copy of its data, usually defined as a struct, enum, or tuple. So if you create an instance and pass it along to someone, they will have their own copy or clone. It's like sharing a recipe with people. If you share a recipe with someone, you have your own recipe. The other person or whoever looks at your recipe will have their own copy. Now, if they modify their copy of the recipe, nothing will affect the others. So if you have one and the other person has one, and you or the other person changes it, nothing will happen to your recipe or the other person's recipe. So that's what is called value type. And second type is reference types, where different instances share a single copy of the data, and the type is usually defined as a class. More like if you cook fried rice and you pass it along, if someone takes a bite, it will affect the overall quantity of the fried rice. I personally don't like to share my food, Just kidding. But yeah, reference types is basically one bowl and everyone can look at it, and when someone accesses it, the overall item is updated. So make sure you remember your data type properly. It's very important to know who the value type is and who the reference type is, since it affects the overall mapping of objects in the code. Constants. Now that we have everything set up, playgrounds, Xcode downloaded, everything ready, let's start with our first type, which is constants. Constants refer to a fixed value that our code may not change or modify during its execution. Constant can be of any of the basic types, which we'll look in some of the future videos, like int, double, float. We've not done any of the types. There are enumerations also, which we'll learn in things that we'll learn in future, which can be constants. So how do we declare constants? Or what I mean is, tell the system that anything is constant. And the answer is, you must declare them using the let keyword. That's the key. Let keyword, L-E-T. So constants are nothing but something that doesn't change. So that's just from the name itself, we can say it's more like, let's say, what is my cuisine recipe, or how many number of plates do I have? Am I hungry? And I can set these things constant, like my name is constant. It's within a run. It's not going to change. I mean, unless I want to change it, but I don't. And my age, that can be a variable because it can change, and it does change day by day. I'm getting old. So let's look at some common constants, or how do we actually run this. So I already created a Swift project here, or a playground, and let's say let my name equal to so that's how you kind of define. You say use the let keyword, you can give the name of the constant that you want to use. Mostly this is called as camel case character. There's also capitalized camel case, which is the first letter is capitalized. There is all small case, all lowercase. Usually during methods and names of constants and variables, we use camel case. So we start with, so if let's say my name during the recording, so it's easier to kind of read for anyone who's looking at this variable or a function or anything that we do in future. Whereas classes, they have usually classes, structs, enums, they have capitalized letters. We'll see them as and when we use them. So this is what it is. So let's say my recipe is awesome food. Some constants that you can define. Now it's not only true for strings. In this case, if you see anything that is inside quotes is a string. I can also say let number of plates equal to 4. In this I've given a number, so you can give int, you can give also boolean let am I hungry equal to true, and you can give, for boolean you can give true or false values. For numbers you can have integer numbers, you can have boolean, you can have double numbers, you can have floating point numbers, you can have strings. So there are a lot of different things that we will cover and we will learn as and when we go in future. So this is how you can declare a constant, by giving the keyword let, the name of the variable, or sorry, the name of the constant, and the value of that particular constant. It's not going to change. So even if I try to say am I hungry equal to false, the compiler will give me an error saying that what are you trying to do? Are you trying to update something that you have set as constant, and you can't actually change that. So if you see the error right here, so that's how constants work. Once declared, it never can be changed. Variables, as the name says, variables, something that keep on changing as and when the time goes, or where as and when the program goes further. We've looked at constants before, where it says the constant is something that you can never change, whereas variables on the other hand are some items or names that you give and give it some value which can change the value in future. It's like I am going to take my first ingredient, which is let's say rice, and initially it's uncooked rice, so my variable says type of rice, uncooked rice. As in when I cook it, the rice changes, it becomes cooked as in when I cook it. So the value of that same variable will be cooked rice from uncooked rice. I can say am I hungry to true, and as in when let's say I eat something and then I come back and someone asks me are you hungry, I say false. So I'm changing the variable name, so that's why they're called variables, because their values can change, unlike constants where the value doesn't change. How do you create variables? You create variables using the keyword var, var, just the three first letters of variable, var. So let's look at how we create variables. So I can just say variable, say my age, which is, let's say, 40, and if I say my age equal to 50, so if I'm changing my variable from 40 to 50, and if you see on the right side, it will display me 40 and 50. I can keep on changing as many times as, unlike constants where you give some value and if you try to change it, it's going to give you error. For values that keep on changing, variable is the best preferred way of defining them and then using them throughout your code. Another thing that I can do is, let's say, variable time of day equal to morning, and after some time I can say time of day equal to afternoon, and as the time goes on, time of day equal to evening, and nights, and so on. So if you see here, I can keep on changing the name, the value that I'm giving to this particular variable, because it is a variable, it keeps on changing. I can also have variable did I eat anything of the type bool, saying false because I didn't eat anything. After some time, after, let's say, I had some food, and did I eat anything, I can just say true. So you can set the value of that, or change the value of the variable as in when you do something inside your code. So that's why variables are used, and we'll be using a lot of variables throughout our applications and projects that we're going to work on, and you'll see how they are so handy. Comments are just comments. So let's say if I cook something for you, and once you eat it or once you smell it, you're going to give me some kind of comment on the food that I cooked, or the taste that it tasted, or whatever you have to say about that. So, and similar thing that can be used is in, like, let's say you posted a blog about something, or a video blog, or posted something on Facebook. People will comment on it. So these are comments. But what does comments actually mean in programming language? It's another a way that you specify something in your code that other people will see, but it will not be compiled by the compiler. The compiler will not see it. It's just invisible to the compiler. It's just some to-do notes, or notes that kind of explain the code better. So let me give you an example. I have this playground here. It has three different things, 3 lines of code. First one says this is constant, which has a value 23 assigned to it. I have a variable that I've created, called it awesome variable. And if you see, not so awesome after all, because I can change this variable's value. Now what am I doing here? I mean, I'm just creating some basic random variables and constants. But how do I tell other people that I'm doing that? So what you can do is, you probably add comments here by using /. This is how you add single line comments, where you can say this is a constant. I can say this here is a variable. Here we are modifying the variable. If you look on the right side or in the debug area, nothing has affected the output of this particular program, just that it helps us, someone who's looking at it, to read and understand what am I trying to do here. This is how you add single line comments. Now what if you want to add multiple line comments? For example, I say this code was written by on 1st March 2018. So if I specify that, how do I make this as a comment? So do I do comment? So single line. Now it becomes very tedious. What you can do is, you can leave it as it is, put / and star as the start of a multi-line comment, and at the end */, and you can keep on adding as many comments as you want. At a time unknown in a far away world and whatever you want to write in there. So that's how you can give single line comments in your code and multiple line comments. Comments are very helpful, especially when you're working in a team or you have to give this code to someone else. They can just look at these comments and kind of figure out what you're trying to do in the code if they don't understand. So that way they don't have to come back to you and ask you questions. So this is very good for maintenance or for projects that run long term, where you're working on a project and then you give it to someone else, or even when you're working on a project after 3 years, you want to update that project, you come back to the project and you're like, what the hell am I doing here? So you want to kind of modify that. So that's where it kind of comments help you to make sure you understand even in future what did you do in your code. So that's what comments are helpful for. Logging is very useful to kind of see what you've been working on or what you're doing as and when you do it. So let's say you are doing a task of cooking, so and you want to log every single event that you do. So first thing, open the recipe. So that's a log, and then you go ahead and open the recipe. Next, you say log that I am heating the oil, which is what is written in the recipe. So that's something that you log. And after cooking for a little while, you say, okay, the food is cooked. You log saying, okay, food is cooked. So this is logging kind of helps you see all the different steps that you've been going through in the debug area in your project, because when the code is running and you're trying to debug the code, you don't know if it went through all the steps or not. So the best way to do that is using the print function. We kind of saw that before, but just look at print function in more detail. So I've already created a project. I have a single line comment here which we learned recently saying logging, and now if you want to print something, I can say print, and then inside that I can give whatever I want to do. I can give numbers and it will try to print that, but there you go, there's the print number. You can print doubles, floats, you can print strings, you can print whatever you want. You want to print some constants and say food equal to fried rice, variable time to cook equal to 30, and I can go ahead and say food. So I can print out constants, I can print out time to cook, should not have removed that, food. I can print these out as many things as I want, and I can do things in between. So this kind of helps you in the logging area of what's happening. There's different things that you can print too other than these things. Is, let's say if you want to print multiple things together, you can always comma separate them, and instead of printing them in two different lines, you can print them in one single line. You can also print ranges, where I can say 1 dot 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 5. This will give you a range from 1 to 5, and that's what's gonna print out here. You can print out multiple numbers. You can print out, let's say there's another function which is print with separator. So what this does is, let's say I want to print 1 2 3 4 and 5, and I want to use a separator string to separate these guys. If I just print this, what you see is, let me comment these guys out. You will see when I print this 1 2 3 4 5. Now if I add that thing separator, say dash dash terminator string, nothing for now, I'll come back to this. So when I do dash dash, you'll see that before, when it had no dashes, it printed 1 2 3 4 5. Now once I have this, it will print out. Xcode is not working for me here, but if you see on the side, it will print out 1 dash dash 2 dash dash 3 dash dash 4 and 5. Can I add something else here? Let me just do this, make sure it resets itself. Sometimes you do these things to reset it. Run this code, and if you see here, it's displaying here but it's not displaying here, so I'm going to just skip that, and I can add are the numbers. So when I do this, it will take that and put the terminator string at the end of this particular variable. So that's how you can log different things inside your application and see what's happening during your code when you want to look at some variable code of what's happening, of what is the value of it at different points. You can use this without even stopping the project of what the values are. So that's what logging is used for. Type inference. Now Swift, what I call it, is a very safe language. When you assign like an initial value to a variable, the Swift compiler will automatically know what its type is. So you don't have to specify if it's an int, bool, or if it's a string. It looks at the value and then kind of knows what it is, what you're trying to do with it. If you need an empty variable with no initial value, you will need to use something called as type annotation to tell Swift what to expect later on when it's compiling the project, of what is this value type. So you can specify if it's int, double, so you can kind of explicitly do that. So let's look at some of the type inference or how we use it. So I've created a playground and I can create a variable my name equal to. So in this case, it knows that the name is Vivin Arana. If I try to kind of change it, it already knows that it's a string, and I'm trying to specify int here, and it's going to kind of give you an error saying that, hey, you're trying to assign an int to a string that you said before. Are you sure you want to do that? So kind of very smart and lets us know what it is. Now let's say if I'm kind of want to explicitly specify what type it is, you can use type annotation. So I can say variable my age and I can specify int. I don't want to. So now the compiler knows that if I say my age equal to 23, it knows it will error out because I'm saying that it's of the type int and I'm assigning the value 23, which is a string. So it will say, oh, excuse me, what are you doing? So I have to make sure that I have to specify an int value to it, and you can't even give my age equal to 34.5. No, that's not allowed to, because it's an integer and you're trying to give it a double value or a double value. It will kind of try to say, hey, stop, you're not allowed to do this. Another thing that you can do is have multiple variables have type annotations. For example, I can say my age, my street number, and my zip code are all of the type int. So you can specify multiple items as integer together. Okay, since I've used this before here, so it's gonna give me an error. I'm gonna comment this out just to show you this example, and there you go, it works for multiple objects. And then you can give them values. You can say my age equal to 34, my street number equal to 45, my zip code equal to 3434343, something like that. And if I print it out, oops, wrong one. If I print it out, it will display out this option. So type inference or type safety is very important here, and it kind of helps you make sure that you don't do mistakes while assigning. And also, if you kind of forget to assign the type to it, it will automatically know, unlike other programming languages where you have to specifically say what type it is. So this is a very important thing and very interesting, and makes much easier for a programmer to code. Basic operators. Now while programming, you'll come across a lot of times when you want to do some arithmetic or some comparison, some compound assignments, or some modulo operator, kind of getting the remainder of some bunch of different variables. So this is where basic operators come into picture. And let's look at some basic arithmetic operators first, followed by modulo operator, and then look at some compound assignments, and finally comparisons. So let's start with the project. I always have a playground running. I'm going to start with basic arithmetic operators, which include our addition, subtraction, we have multiplication, and we have division. So let's get rid of comma. So let's say I have a variable x equal to 4, and I have a variable y equal to 5. And I want to do a addition of these. I can just do x plus y, and if you guessed it by now, the answer should be 9, and that's what you get out of it. You can do a bunch of different calculations x minus y. You can do multiplication and you can do division to this, and you'll find your solution displayed here. So you're giving me 0 here because both of them are of the type int, and you try to divide one number over another and you're not specifying it's a double, so it's going to give you 4 divided by 5, and 5 0 point something is 4. So that's why it's giving, it's kind of it's removing it's dropping all the things after the decimal and just giving you the integer, which is 0 in this case. So that's how you can do it, and you can do it multiple operator types. You can do print x plus y multiply by a, or you can say multiply by 23, divide by 10, add 45. So you can do a bunch of different operations. Okay, let me just show there's enough space in there. Bunch of different operations together in one single line, and it will give you a solution based on this math that it did here. So this is how you can do basic arithmetic operation. Next is modulo operators. So let's say if I have two values and I want to display what is x modulo y, which means the remainder. So in this case, so x divided by 5. Now if I say x divided by 5, I have, since x is not divisible by 5, it's going to give me 4. If I specify here 4, it's going to give me 0 because 5 into 8 is 40 and the remainder is 0. If I say 41, it should give me 1 because 5 into 8 is 40 and remainder is 1. So that's how modulo operator works. You can try different things. Say 10, 9, since 9 multiplied by 1 is 9, and then the remainder 1, you'll see the output as 1. So that's how modulo operator works. Let's look at some compound assignments next. So compound assignments is, let's say if I say x plus equal to 6, value of x is 10 first, and if I say plus equal to 6, what it does is it pretty much does what is the value of x plus 6. So it's 10 plus 6, 16 is what it's going to assign. So this is shorthand of doing it. So I can just say something like this, and it will take the existing value of x and add 6 to it. And this is true for even multiplication. 10 multiplied by 6 is 60. You have 6. Same thing for division. 10 divided by 6, 1, and rest of the decimals are dropped. Similar, -2, 10 minus 6, and it should give me an answer of 4. So these are the different compound or assignments that are available with this. You can also do modulo with this. So it should be 4 because 6 1 the 6, and then there's 4 remainder, so it will give me the value 4. You can also do comparisons of numbers. I can just say, so comparison operators are equal to, you can check if two numbers are equal. You can say not equal to, you can check greater than, or sorry, less than. You can look at greater than, you can say less than equal to, you can do greater than equal to. So I can say if x equal to y, so this is a loop which we have not seen yet, but I can just say print, just so that we don't go into loop. So if I say is x equal to y, it's going to give me false because x and y are not equal. If I give both the values same value, it will say true. If I say, let's go back to the previous condition, is it's not equal to y, and it's going to give me true because x is not equal to this. Let's give a little bit space. X is not equal to y, true. I can say is x less than y, it will say false because x is 10 and y is 9. Let's ask for greater than. Is x greater than y? It says true, yes, because 10 is greater than 9. Similarly, we can use less than equal to or greater than equal to for this particular case. So this is how we use our comparisons, and these are the basic operators that are available. These operators plus minus for arithmetic operations, and then we have modulo operator, and we had the compounded assignments, which are plus equal to, minus equal to, multiply equal to, slash equal to, which is for divide, and modulo equal to, and finally our comparisons. So these are some of the basic operators that you'll be using throughout your code when you write your application. Ternary operators. Now this ternary operator is very interesting because it does a lot of things in one single line while assigning a value to a particular variable. It checks for an assignment and sees if it's true or false. If it's true, it assigns a value. If it's false, it assigns something different. So it does everything in one single line. For now, for example, we have set, let's say, let my is my food ready. So I can say yes or no, and it will take that value. But let's say I want to decide this based on the time. So let's say let time equal to 11, and I can say is my food ready, is time greater than 12. If it's more than 12 or greater than or equal to 12, I want to say that your food is ready, yes, else I want to say no, it's not ready. So in this case, since it's 11, which is less than 12, so it's going to say no. If it was 16, it will say yes, because that's how this ternary operator works. And since time was 16, it's greater than 12, it's going to go to the first one. If not, it's going to go to the second one. You can always give it a different type of value too. I can say true and false, boolean values. You can give boolean values, string values, numbers, anything that you feel like in ternary operators, but you do everything in one single case. If this is true, then use this. If this is false, then use anything that is after the colon. So ternary operators are usually displayed like this, just symbolic purpose, but this is how the actual implementation of ternary operators are, and a very useful tool if you want to write one line comparison and assign it to a value. Logical operators. Now there are three types of logical operators that we use quite often inside a programming language. One is the bang operator, which kind of negates thing or checks if something is equal to something or not. So logical operator and kind of converts or flips the value of a particular variable. And then there is and. And is used by using two ampersand signs. And then there is or, which is used by using two pipe characters next to each other. Let's look at some of these operators and how they can be useful. So I can say variable am I hungry equal to true. Once I assign this, the value of am I hungry is true, and I can, let's say, eat something, and then once I eat something, I can say am I hungry equal to not am I hungry. So what it will do is it will set the value of am I hungry to false. So that's how this operator works. I can also say print am I hungry here, and it's going to display me back true, because the initial value was true. I said am I hungry is not true, so not true, which means false, and it's assigned to it. And again I'm saying print not false, that is true. And that's how it works. I can always comment this out, and am I hungry, eat something, and then print am I hungry now? Nope, false. So that's how this bang operator, or in this case not operator, works. Next we have and logical and operator. So let's say variable I am hungry equal to true, and I have variable I got some food equal to false. Now I can say print, if I say I am hungry, it will display me true. If I say am I hungry and I got some food, it will give me false, because one of them is false. In case of and operator, or double ampersand in this case, is which represents the and operator, if any one of them is false, it's going to display false. If both of them are true, it will display true. If one of them is false, it's false, and both of them are false, and false is false. So that's how it works in and sign. What about or? So if I use or, am I I am hungry, which is false. I got some food, which is false. In this case, both of them are false, so we have to use one of them, and both of them are false. This is logical OR operator. If any one of them is true, it becomes true. This or this, whichever. So it's more like an optimist, whereas AND is more like pessimist. So if even any one of them is true, it will say true. If anyone is both of them are false, that's the only time it will say false. But if any one of them is true, it will give you true. So that's how logical OR works, and logical AND is totally opposite, where if any one of them is false, it will tell you false. So that's how logical operators work, and these are the logical operators that we'll be using throughout our applications. Strings. Now we have used strings quite a lot in the previous few chapters or videos, but now let's dedicate one single video to strings, because there's a lot of things to strings that we don't know yet. There are a lot of different ways of initializing it. How do we concatenate two different strings? What is string interpolation? And some simple methods that strings provide us, which can be helpful for doing different operations. So let's go and look at some strings. I've already created a playground file for us, and let's create a variable. We'll call it my recipe. You can create a string as an empty string by just saying just giving empty quotes. So there you go, and it will print out for me empty quote saying that this is an empty string which nothing has. So even though it is empty string, it is still a string. So you don't kind of confuse it with nil, because it has a value, and that value is empty string value. You can always create a string using my, let's say, other recipe equal to string. This is another way of initializing a string, and if you look at the output for this, it will print out as an empty string too, because it is an empty string. Because when you say string with these brackets over here, you're actually saying that I want to create a string object which is empty. Now how do we concatenate two different strings? So let's look at that. You can say variable food type equal to rice, and if I say variable recipe equal to fried. So and if I want to concatenate these two strings, I can say variable recipe equal to, or my recipe equal to recipe plus food type. Now when I do this, when I add two strings, what it does is it will give me an error here saying invalid redeclaration of my recipe, because I have defined it here. So I'm going to just remove this and then say my recipe is recipe plus food type. Now if you see, it creates a single string fried rice with both of them. I can also add a space if I want by just doing this, and I'm adding three different strings together. So that's how you can concatenate strings, just by adding a plus sign and putting strings in either side of plus signs. So that's how you can concatenate. Next thing, let's say string interpolation. What is string interpolation? Probably hear this quite a lot. I'm going to say welcome to my kitchen where I will cook. Now I can do plus and say my recipe. This is what we learned. This is how you can concatenate two strings. But what if I want to put this in between the sentence? So then I'll have to do plus and then again do something like this, and it will add this dot at the end of the statement. But what if I don't want this? It looks very messy. So what you can do is you can do string interpolation, where you can put the variable inside it and just do the slash and open bracket and close bracket and then close it. So it's more like you're escaping that particular thing and saying that this is my string. So this is what string interpolation is, where you write the entire string and in between you just add your variable, but make sure that you surround your variable with slash and these brackets. So that's string interpolation. Let's look at some of the methods that I have. I can always use, let's say, my recipe dot count. This is one of the methods that's available. What it does is it will take the number of item 1 2 3 4 5 6, 7, 8, 9, and then they've added space to my recipe, so it's going to count the total characters that it has, and that's where it displays it. If I had not added this, it will say 9. So that's how this works. If I remove one of these variables, fried rice, and I have that displayed as 8. So that's one of the very important thing that you'll probably be using it quite a lot in future. Another important one is the string empty, something that we can use, and since I have some value inside it, it's going to say false, it's not empty. How about my other recipe? Is my other recipe empty? It says true. The reason it says true is because I have just initialized this variable and I've not assigned anything. It's an empty string, which we spoke about here. If you look at this, the value is empty and I've never used it anywhere else, so that's why this string is empty. So this is some of the basics of strings, and we'll learn more about some more functionality about strings in the next video. More strings. In the previous video we saw how to use strings, and we've used strings quite a lot of places till now. We also saw how we concatenate two strings. We saw what string interpolation is. We saw how some of the methods like count or isEmpty. Let's look at some more methods of strings that are available and are very helpful in future to use. So let's go ahead, and I've created a playground. I'm going to say food equal to fried. So I've created a variable which is named as food, and I've called the value as fried. Next, I can check, as from before, we can check count. How long is this string? It will tell me that it has 5 different characters. I can also say, does it contains a particular element? So for example, I say capital F. It does contain, so it's going to say is there. You can search for R. It will say yes, it contains. You can also look for small characters. Now in this case, if you look at it, does food contains the small f? It doesn't, so it will give you false. The reason it's giving you false is it's case sensitive, and it will only look for case sensitive items. So if I give small f, it will not work. It will only work if I give capital F. Okay. So it does contain that string, and it will give me that particular value. I can also say food dot append and try to append something to my string. I can say, okay, I want to append space rice So now what is the value of my variable food? It's fried rice with the exclamation mark. So this is how you can append two different strings together with fried and rice. But what if I want to add something in between these particular strings, or append something inside, or insert something inside a particular string? So I can just say insert, and I can insert one more exclamation mark at the end of this particular string, or at some point in between. So I can just say string index, let's say if I say 2, what happens in this case? So in this case it will say that, oh, unexpected value, but I can do is food dot and specify, let's say, start index. So this will take the start index of this, and if you see it, added exclamation mark in the front and at the end. What if I want to remove a particular thing? So I can say insert new element, or sorry, not insert, I want to remove it. So what I'm going to do is I'm going to say call the function remove, and at index is asking which index do you want to add. Now in this case, if I say food dot, let's say, start index, see what happens here. It's going to say this is the variable that you want to remove. What is the value that I get though for food? So as soon as that's done, it's going to remove that. But can I remove the exclamation at the end? Let's see. Remove at index food dot end index. If I specify this, what do I get in this case? I'll get an error, because it's trying to, you're giving an index at the end of it, and since the indexes start from 0, it's going to not work for us. So what you do is you specify that you want to remove a particular object, food dot index, there you go, after, or sorry, not after, because after is after everything is done, but I want to do is before. Just clean this up. Before, okay, so it's make sure this function shows up. me try to do this one more time. Add string, and I can say food dot index before, there you go, food dot end index. So before the last index I want to remove that object, and this one will show me an exclamation mark as soon as this error goes away. Sometimes what you can do is you can just copy this entire thing, cut it out, and let it run. This is one of the debugging techniques with playgrounds, because it doesn't work sometimes. So there you go, now it works. You can print food here, or not, just display food here, and you'll see that initially when I had fried rice, I added exclamation mark at the end, then I inserted one in the front at the start index. I removed the start index one using this, and I displayed it, and you see it disappeared. And then I added then I removed the character at the end of it by using this remove function and saying food index before the end of the last object. So that's when it removed the character, which is the last character, and we have the fried rice now. You can always do something called as separate the strings. So I can say food dot, use something called a split for that. This is a very important function I'll be using quite a lot. You can say, what character do I want to use? I want to use the character space. Now in my particular case, I have one space in between fried and rice, so it shows that it kind of separated them into an array of two objects. We'll learn arrays in future, but that's what it does here. If I had more objects here, awesome, fried rice, awesome, and then you have fried rice, awesome. So we have, since there's two spaces, it will kind of separate them out. You can separate them out with different types of characters that you have available. So this is more about more strings and how you can do all these different functions, and something that is already available for you, and you don't have to worry about writing code for this. These are like convenience methods that are provided by iOS or Swift to you. Numbers. Now I played with strings quite a lot. Now let's look at numbers. So numbers, you can do bunch of different operations. I mean, there are different types of numbers. There's integers, there's float, there's double. So how do you kind of make sure that when you go from one number to another, or do a math on one number to another number, how do you make sure that you keep the consistency or get what you expect from it? So let's look at some examples for that. So I'm going to start with a project playground here, and I will start with, let's say, a number. Give a number equal to, let's say, 3.4. In this case, it will take the value of double here, so the type of a number is double right now. Now if I create another number, say b number, and then say that this is integer, and I try to assign it a number, it will not work because I'm trying to assign a decimal number to an integer number. It will give me an error right over here, and it will say cannot convert value of type double to specified type int. And the solution is, how about you kind of cast it? So you can actually cast a number by using int in front of it. So casting meaning you're taking a number which is double and casting it into integer type. So if you see here, it's converted into this type. It's not rounding the value, it's casting it, so by just dropping the decimal point. So even if I give 3.99, you'll see the value is still 3 because it doesn't take the number of, if I say 6.99, it will just give me the value 6. So it's just casting the value and converting the number into an integer. Another thing that I can do is, how about variable c string is of the type string. So can I convert this, or do I have to specifically say this? If I specify the number that a number, c string is a number, it will take c string as a decimal, but I want this as a string. So what I can do is I can just cast to string, and now the value that I have for c string is a string value. So if you see here, it's a string value. It looks like a number, but it's a string because it has quotes around it. So this is a very tricky question. A lot of people sometimes ask, okay, what is quotes 6.99? It's not a number, it's a string, because anything inside the quotes are strings. So that's how you can convert a number into a string, and it will take the form as a string, and inside that you'll see the number, but it's not a number, it's a string. Remember that. Now let's say if I have two numbers, let's say a number and b number, and if I want to create d number, and I want to add a number plus b number, what type is it in this case? So this value was, let's see this value, I think stopped working again. Let me just do this and run it again one more time. A number 6.99, B number is int of a number, so it should be 6. And now I'm trying to add two numbers, a number which is a double value and b number which is a string value. In this case, if you see, it cannot be applied to operands, so it's not kind of showing me display here, but it's saying that I am not able to convert this into that. So what I'm going to do is I'm going to take a number and b number which is int. I'm going to say let's cast this to double, and I have d number as 12.66. I can do another thing, which is, let's say z number equal to 34 plus 2.34. Now in this case we have not specified what these numbers are, and it's automatically going to add these numbers and take the precedence of a double variable. So if you're not assigning anything, if you're not setting these variables, you don't have to cast it, it will automatically cast it for you. So that's pretty smart of this. So that's how numbers, you can do some calculations with numbers, play around with them using the casting functionality. It's not only true for numbers, you can do this for anything, but this is a good start point, and this is where you'll be using quite a lot and do a lot of mistakes while adding numbers, multiplying numbers. Sometimes if you have a string number and you're trying to add two string numbers, they'll become one single huge string and not a number. So be careful with what you do with calculations or castings. Booleans. We've seen booleans being used before. There are two types of booleans, true and false values. So every time you create a variable and assign it of the type boolean, you can only give true or false. You can't give numbers to it. In some programming languages you can give 0 or 1, but in Swift you can't give numbers. Let me show an example with a project. I can say where my value, let's say, is of the type bool equal to 0. So this is possible in Objective-C or maybe some other programming languages, but it's not possible in Swift. You have to specify specifically true or false values. So if I say my other value is false, and you don't have to specify this bool, I'm just did that just to show you the case where, because if I don't do that and specify 0, it will take it as an integer. So now in this case it knows that this is boolean value and it will assign the value false to it. So there are only two types of values in case of bool, true or false. It's usually used for checking some conditions or making sure you are going through a particular path where you can again check for conditions, and that's something that we'll look at more in when we write conditional code. Another thing that you can do in a shorthand is, which we looked at, logical operators, where you can use the AND operator. So I can say where is this variable available equal to, I think I can say my val, so the value of this guy will be true. If I say not my val, it will take not true and assign this value false. So it's a very interesting or very important things where you can actually write this, use this bang operator or not operator to do a lot of calculations or do things inside loops where it will flip the value of the particular boolean to totally something different in this particular case. Arrays. Swift arrays are used to store ordered list of values of the same time. They're like collections, and this is the subject about section about collections and Swift collections specifically, and arrays is the most commonly used collection. They are ordered and they are indexed from, let's start from 0. So let's say if you have 3 items, you have the first item is at index 0, the second item is at index 1, and the third item is at index 2. Swift puts restrictions which does not allow you to enter a wrong type in an array. Even if you try, it will give in compiler error. If you assign a created array to a variable, then it's always mutable, which means you can change it, add, remove, insert, do a bunch of different operations. But if you assign an array to a constant, then the array is immutable and its size and contents cannot be changed. It's like fixed, and same as any other types we have looked at before when we looked at variables and constants. So as per my kitchen, I can create an array of all the pots and pans I have and store it in that particular object. Also, I can create an array of all my recipes in a variable and keep on adding more when I have more. So it's a very integral part of Swift programming. Here is how you can create arrays. Let's start with a playground. I've already created one and I'm gonna create an empty array. The way to create an empty array is, say my recipes is the name of my array. I can say, like, if you have to create a string object, you just have to create it this way. But if you want to create a string array, which means a collection of string objects, let me show you how an array usually is represented. So let's say 1, 2, 3. So if you see here, this is an array of 3 items inside it, and all of them are of the type string. So that's what I'm creating here. I'm creating a container, my recipes, which will contain strings, and you can add as many as you want. Also, you can create an array with a particular size and initialize it. So if you exactly know how big the array is, you can say, let's say or meals, which are breakfast, lunch, and dinner, and I can say string array, and I can say it's, let's say, repeating. I'll just add some placeholder, meals, and count equal to 3. So it's going to create an array with 3 items, and all 3 of them are meals right now. You can go ahead and change it by just probably mostly doing, you can access it by its variable. Let's say 0 equal to breakfast. Now when I look at meals here, probably see I added meals, but when I go ahead and add modified, it shows me this thing. So this is a way to actually access them, which we'll look at it in a little while. Another way of creating an array and assign some default values to it. So for example, I want to look at all the different meal times. So let's say when is my breakfast. There's another way, like we have created integer types by doing this, but you can also do an array by setting up brackets around it. And if I want to assign it some values, I can say 8 AM is when my breakfast is, 12 is when my lunch is, and 19 is, which is 7 PM, is when my dinner is. So I can add items like this and then create an array with that particular object. You can add anything, and in this case I created a string type. You can create integer, you can create bool, anything you want. You can and we just saw how to retrieve a value and change it, but let's see how do we actually retrieve an item from a particular array. So you can retrieve a value from an array by using the subscript syntax, which means that you can use the square brackets and inside that put the index of the object that you want. For example, I can say, okay, I want to see meal times for my lunch. You can just say 1 because the first object is at index 0, this is 1, and this is 2. So if you see, if I say 1, it will show me 12, which is the first object inside the 0th object, first and second. So that's how it works. Here the index always starts from 0, which means the first element can be accessed using the index as 0, the second element can be accessed using index 1, and so on. So if I want to print out something, let's say I can create a object called as breakfast time equal to, copy this and say meal times at 0. So I can just say print let's use string interpolation, breakfast is at breakfast time, close this, and now you'll see in the debug window it's the breakfast is at 8. I can directly access it. Instead of creating a variable, I can say lunch is at meal times of 1, and similarly I can say dinner is at meals time 1 and then 2. Okay, there you go, and it should print me out breakfast is at what time, lunch is at what time, and dinner is at what time. There you go, that's how it works. Now let's look at how we can add 2 different arrays. So for example, I have this array and I have another array. Let's call it my array just to keep it simple, and inside that I can add 1, 2, and 3. Now you can use the addition operator, the plus operator, to add 2 arrays of the same type, which will yield a new array with the combination of the values from the 2 arrays, and it looks like this. You can say variable my output array equal to my array plus, and you have to make sure they are of the same int type. You can say meals times. Now if I look at this array, it has 1, 2, 3, 8, 12 and 19. 1, 2, 3, 8, 12, 19. That's how you can add couple of arrays. Next thing is, you can always get the count of a particular array, which is more of a read-only property, because what it does is it reads number of objects that are there. I can say my op array, which you see has 6 items inside this, dot count, and this will print out 6, saying that there are 6 items inside the particular array. You can always check if a particular array, op array, is empty. So this will give me true or false. Since it has items inside it, it will give me true. But how about recipes? We've never added anything inside recipes. Is it empty? Yes, it is true. So you can check these things. These are kind of helpful when you're doing some operations with array to check if there's empty or not. You're trying to do some calculations, but you want to do that beforehand. So this is very handy. So this is how you can use arrays. We'll look at more on how to what all different methods are available in arrays in the next section. Array methods. Now that we know how to use arrays, let's look at some of the methods that are available, or functions that are available that array lets us do, or something that is already been provided to us, which we don't have to think too much and use it. In some other programming languages, if you have done any programming languages, you probably know that sometimes to kind of manipulate an array, do things with array, you'll have to write your own functions. But in Swift, we have some functions that are already available to us. Let's look at how to modify arrays. And I've created a empty playground here. I'm going to start with let's say appending items to an array. You can use the append function or append method, or you can use the addition assignment operator, which we used before, plus equal to add a new item to the end of the array. Let's look at an example here. So I say, let's say where my meal times, which we did before, is 8, 12 and 19. So these are different times. I want to add another meal time, let's say my midnight meal, to add one more item. So I can just do my meals dot append, and I can add one more item in integer to it. So let's say that is at 24, or I can say at 0, almost 24 hours. So I'm going to add that 0 over there. So midnight snack is what I've added at the end of it. I can also add items to it. My meal times plus equal to, let's say I've got hungry again at 4 AM. Since I'm working late, I can say that I can add an item, something like this, where it will append this to the end of the body. Now this is giving me an array, because you can't append an object directly like this using this operator. What you have to do is you have to add it inside an array object. So since you are adding an array to another array, so the same as what we did in addition last class. So similar thing. So here you go, we have added this item to our meals item. So this is how you can kind of append items. If I want to access them, again we know how to do that. My meal times, if I say 0, 1, 2, 3, 4, I'll get my item that I've added at the end, and that's how you can display these items out. So that's how you can modify and append items to an array. Another thing that we can do is we can do some inserts at a particular location. Now in this case, append or plus equal to, we are adding to the end of it. What if I want to add somewhere else? So I can always say my my meal times dot insert, and if you see, it has this object where I can insert, let's say 7 or 6 at integer at index 2. So what this does is it will take 6 and insert it at index 2 and move everything to the right. So 19, which was at 2 now it's at 3. So if you see, I have 8, 12, 6, 19, 0, 4. It doesn't make any sense that I'm gonna just make it 16, which makes that at 4 PM I'm gonna have another meal. So I've inserted it there. So that's how you can insert items. You can also remove items. Say I want to remove an item from, I don't want to have breakfast anymore, so I want to remove that item at index 0. So it will say that you will remove 8. So it's going to print out this for you. If I want to display what all different things are left, you'll see that 12 is now moved at index 0 and everyone is moved 1 to the left. So that's how you can remove items. You can remove it any place. It doesn't have to be at the start. You can assign any location. So if you see now 4 is removed, which is at the end. You can remove something from the center, which is 19. If I want to remove that, since I'm having something at early, let's say dinner, I don't want to have another dinner, so I can remove that. So that's another one. You can always reverse an array. I can say dot reverse, and now you'll see that entire array that I had is reversed. So I know that it's in some programming language you don't have this option, and you'll have to write some loops and things, and becomes very messy. But in this case, we can directly use the reverse function. It does it for us. You can also check if something is available in an array. I can say, does it contain the element 4? And it will give me whether it contains the element 4 or not. And if you say true, if I say, does it contain 16? And it will tell me if it contains or not. So there you go. That's how it works. So the contains is useful when you want to check if something is existing and you don't want to add again. So that's how that works. You can also create nested arrays. Till now we've seen only one-dimensional arrays, but you can have more than one-dimensional arrays. What does it mean? So that means an array of arrays. So I can say this array, which is usually when we create an array of strings, we just say this is how we declare an array. But multi-dimensional array, you can array. This is two-dimensional array where you have an array inside an array, and you can kind of create it like this. So this is the main array. The first element is an array inside this. So at index 0, I have another array. I can say 1, or since it's a string, I can say 1, 2, and 3. I can create the second element inside the main array, and I can say that this is 11, 12, and 13. So I have, this is 2 by 2 array because the main array has two elements, 0 and 1, and inside that I have 1, 2, and 3. So it's actually 2 by 3 array. Sorry. You can add more elements inside this. You can add 14, 15, 16. They can be various styles. You don't have to be 2 by 3. It can be 2 by 7. It can be 7 by 14, or it can be anyhow you want it. So how do I get access to these objects inside here? I can say this array, if I set items index 0, it will give me 1, 2, 3 as output. There you go. If I want to get something at index 1, which is 2, here I'll have to say 1. If I want the first one, I'll say 0. So it'll say 1 here. If I want to go to the second one, I want to display 11, display that for me. So that's how our arrays works. These are some of the methods that are very interesting, and we'll be using it quite often. And multi-dimensional arrays are much helpful. You can have 3-dimensional array, 4-dimensional array. You can kind of make it way complicated and use the arrays. Dictionaries. Swift dictionaries are used to store unordered list of values of the same type. Unlike arrays where we had ordered list of items, in dictionaries we have unordered lists. So how do we access it? Actually, dictionaries has a different type. What Swift does is, what dictionaries do is, it has a key value pairs. But also you have to make sure that Swift, when you put some value inside a dictionary, you can't enter a wrong type than what you have assigned, because Swift has a very strict checking which does not allow you to enter a wrong type in a dictionary, which will result in a compile time error. Swift 4 dictionaries specifically use unique identifier known as key to store a value, which later can be referenced and looked up through the same key. So it has like a key and a value. So every single item has a key value. Unlike items in an array, items in dictionaries do not have a specific order. You'll see that when we look at an example. You can use dictionary when you need to look up values based on their identifiers. A dictionary key can be either an integer or a string or any kind that you want. There's no restrictions on that. It depends on what you specify. But once you specify, you have to make sure you use that particular type. And again, it has to be unique within a dictionary. A dictionary can't have two keys with the same numbers or names or whatever you're using. If you assign a created dictionary to a variable, then it's always mutable, same as dictionary or same as any other variable, which means you can change it, you can add, remove, change items inside it. But if you assign it to a constant, then you have to be careful, it's immutable, which means you cannot change the size, you cannot change anything inside it. Now another thing that you have to remember is, since it's not based on numbers like an array, dictionaries, the key values or values specifically are optional. So if you say that I want to look for a particular key and that value doesn't exist, your application might crash. So that's why they made it optional, and you'll have to unwrap it using whatever method you use. So let's go ahead and see how dictionaries work. Let's go and create a particular dictionary. I have already a playground available here. What I'm going to do is I'm going to create a variable and I call it my recipes, and I'll show you how to kind of create or initialize. One of the methods is you can give the key type here. So I'm going to say key type int and value type string, because I'm going to say first recipe, second recipe, third recipe. Again, I can use for this particular thing I can use arrays, but just to show you an example. Another example I can say is, let's say meal times, okay, which is my another common example. You can assign it even by doing this. I can say this is a dictionary which is int and string type. I'll assign it some values. I'll say, so if you see, I'm not using any numbers as 0, 1, 2, 3. I'm going to say at 8 o'clock I will have breakfast. Oops, it's a string, so I'm going to assign it string. At noon I will have my lunch, and at 7 I'll have my dinner. And now when you look at it on the side here, if you see, I've given 8, 12 and 19, but it's showing me 12, 8 and 19. So it doesn't have an order. It can show it to you in any way possible. Even if you remember seeing it in array, it had a proper order, 0, 1, 2, 3. It had index. But in here you specify a key and a value, and you can actually access it through these things. Let me show you how you can access these values. So I can say variable most important meal equal to, I can say meal times. This is how you can access. You use the name of the dictionary, and right after that give the key. So now when I see the value of this particular item, most important meal, give it a second, there you go, breakfast. You see the option here. What if I try to print it? Let's go and print it and see what happens. Most important meal is most important meal. Now if you see here, when I try to print this, it will print out as optional because it doesn't know if this key exists or not. That's how dictionaries are built. So what you'll have to do is, I'm going to do forced unwrapping. This is a very bad way if you know that it's not the right thing to do, but in this case I know there's a value, and just for example's sake, and in future you'll probably see how to use these optionals and how to play around with it. It's in one of the section up ahead that we're going to cover. So what happens is, an optional here, just to give a brief introduction, what happens is an optional is something where it wraps up the value inside a box, just so that if the value of that item is nil, it should not crash your application. So that's why if the value of this item was not there, let's say I look for 9, which doesn't exist, it's going to say most important meal is nil. If it was not an optional, it would just crash the application. So since it's an optional, that's how Apple has created it, or Swift has created it. It will not crash your application. Now to access that, now in this case, if I use that exclamation mark, it will crash my application, because I'm saying, okay, display my name, and you see the error shows up. But in this case, since I know, and there's different ways of unwrapping it, this is not the ideal way, this is very wrong to do, but in future we'll learn how to actually access it. This is just for demonstration purposes for a dictionary. Now can do the same thing for others. Print then follows. What does it follow? It follows with lunch, which is at meal times at 12. Then follows dinner. Now if you see here, it will show optional, so all you do is like add this, and we have our print statements for displaying dictionaries. Similar to our arrays, we also have counts. We can look for count of a particular items that are there in our dictionary. So my dictionary, I can say what is the count. It will show me 0 because I just initialized it. I didn't add anything inside it. Meal times dot count. It will tell me that the count is 3. Next is so this is kind of helpful when you're doing something that needs the count of a particular area of how many items do you have, how many key value pairs do you have inside your dictionary. Another thing that you can look at is empty, similar to arrays. Is empty. Is this recipe is empty? It says true because I've just created it, not added anything. I can say meal times, is this empty? It's going to give me false because meal times do have 3 items inside it, so it will update as soon as it updates. This is still running, and there you go, false, because it has items inside it. So these are some of the important or interesting functions that are available, functionality properties that are available for dictionaries and arrays. You can use them for any item that you have. So that's about dictionaries. Dictionary methods. Now we saw how to use dictionaries. Now there are a lot of dictionary methods that are available which we can use, which will help us kind of use dictionaries in a way that we want to, and then get like maybe filtering, maybe put them in a special grouping, or modify the values inside them. So remove, add things inside a dictionary. So let's see how we can do a lot of these things in dictionaries. So let's start. I've already created a new playground, and in here I'm going to create a particular, let's say, meal times. This is similar to what I did in the previous video, but this time I'm gonna turn it around a little bit. I'm gonna say string versus and int. So the key is string and the value is integer. Inside this, I'm going to create my dictionary, which will be, first object is let's say breakfast. What time? 8. So you see what I'm doing here? I'm kind of reversing or the order of key value. Let's say lunch is at, let's increase this size a little bit here. Lunch is at noon, and dinner is at 7. So I have my values over here. I've added these things inside. Now next, let's see how we can use one of the filter methods or filter the values for a dictionary that we have. So I can say variable, let's say early meals equal to, so I give the dictionary here meal times dot, and the function that we're looking for is filter. Let's say filter, and I'm not using any of these, so I'm going to just type it out, filter, and I'm going to open bracket and say the object that is passed, is it value for each and every item that we have, is it less than, let's say 1 o'clock, which is 13. So what it does is it will go through these items and kind of substitute this for each and every object and see is the value less than 13. In this case we have 2 items whose value is less than 13. So if I print it out here, early meals, you'll probably see the 2 items displayed, breakfast and lunch. If I say what is something before 11, do I have, what are the early meals that I have, and it should give me only the breakfast item. So you can kind of filter them out with one single line with the function, and that helps you do this. Another thing that we have is grouping different things. For example, if we're grouping for key values without actually giving items to it. For example, I can say different recipes that I have. Now I'm going to take an array, so it will let me take a bunch of different arrays and then kind of group them together. I'm going to say fried rice, I'm going to say veg noodles, I'm going to say lentil soup, I'm going to say fish fry. So I have 4 different items here. Now how does groupings work? So for this array I want to group them based on their first character. That's how I can want to group them as. So I'm going to say grouped recipes. So this is our dictionary, this is what we'll get here, and what I'm going to do is I'm going to call the dictionary function, and I'm going to say I want to group them by, I have a group. What do I want to group? I want to group recipes. How do I want to group them? I want to group them, look at each and every one of them and take the first character from it and group them based on that. That's what this says. Okay, I think I have everything available here. Now let's look at our groups. So what do we get here? Print, how does this dictionary look like? Grouped recipes. And there you go. We have lentil soup in one, L. We have veg noodles in one. And since both of them have the same starting character, it says fried fish in F. So it groups everything based on their first character and displays it to us. What else can we do in dictionaries? Modifying dictionary. Let's go ahead and see if we can modify any of these dictionaries. You can modify a dictionary by using a function update value, which is a method that is available, and that we can do by, let's take our item here and meal times and update that. So I'm going to say meal times, and the function that I mentioned was update value. Now what is the value that you want to update? So let's say I want to change breakfast, which is at 8 o'clock, to 9 for string breakfast. So I want to change breakfast, which was at 8 o'clock, to 9 o'clock. Now let's look at how does meal times look like. I can say print meal times, and if you look here, I mean, okay, breakfast is at 9. So there you go, perfect. So this is how you can actually change your value. Another way of changing it is you can always say that meal times for, let's say, lunch, I want to set it to 1 o'clock. See how does it look like now. I'm gonna kind of comment those out and let's look at it. So if you see your lunch, which was 12, is changed to 13, and breakfast we changed before, so it changed from, can just show you the difference. So that's one way of doing it, update value. The other way of doing it is just getting the key and then updating the value of it, and it updates the value of it. That's another method of doing it. If you know exactly what you want to change, that's another way of doing it, or use update value. Both of them kind of get you the same thing. How about removing some key value pairs from a dictionary? Now let's say if I want to say so I can say meal times dot remove value, and I want to remove value for, let's pick up actually for key. So I'm gonna say for key breakfast. I'll get rid of breakfast, and let's print this out. What do we get when we print this? So if you see, breakfast is removed. So that's how you can remove items from inside. You can always do something similar to this. I can just say is nil. When I do this and I print my meal times, you'll see lunch is removed. So whenever any key doesn't have a value, it's automatically removed from the dictionary. So these are different things that you can kind of do with your dictionary, where you can filter based on something, you can group items together in an array to a dictionary, you can remove, update, and do these kind of things in a particular dictionary. So that's all for dictionary methods. Sets. Swift sets are used to store distinct values of same type, but they don't have to have definite ordering as arrays have. So they are kind of, you can think of it as mixture of both arrays and dictionaries, but still look like arrays. So there are a bunch of things but not ordered, bunch of items inside an array but they are not ordered. So Swift sets are nothing but bunch of unordered set of items. You can think of it that way. But one thing to know about sets is everything in a set should be unique. That means there are no duplicates allowed inside. So you can use sets instead of arrays if ordering of elements is not an issue, but you have to make sure that you remember that there are no duplicate values. You can't add it. Sets will actually give you an error or compile time error, say if you try to add same items twice. If you try to do it programmatically during runtime, you might see some errors when you try to add things that are already there, or it might give an exception. So let's see how do we create sets, or how do we kind of go ahead in a playground. So I have a playground here, and let's see if I want to create my meal sets equal to, you can say set, and then inside that you can say that it's of the type string and create a set. So that's how you can create or initialize an empty set. You can also do variable my recipe sets and say it's a set, and inside this I can say fried rice, lentil soup, and veg rolls. So something like that. So add one more time thing, fried rice. Now when I run this, you'll probably see on the right side where is the fried rice that I've added to it. What it does is it automatically ignores it. It just says, oh, you're trying to add something to my set which already exists, so it's going to just completely ignore it and get rid of it. So if I add this or don't add it again, it will not make a difference to the set. So that's how sets work. Some of the things that you can do which is similar to arrays and dictionaries is you can say my recipe sets dot count. You can say it, is it empty? You can check that. You can do similar thing with this dot count. You can check if this one is empty, and this will kind of tell you if it's empty or true. My meal sets is empty, so it's going to say true. My recipe is not empty, so it's going to say false. Similarly, count 3 and 0. So that's how you can create sets. Just have to remember that they are unique. They are unordered, and at the same time they can be they can't have similar values repeated inside a set. Set methods. So we saw how you kind of initialize sets. Now let's see what are the different methods that are available that we can use to play around with sets. Now there's insert, remove, contains. We already saw count and is empty method properties, but let's look at how do we add something to set, how do we remove something, and check if something is available inside the set that we want to check for. So for, let's say if I want to insert something to my existing set, I can say my recipe sets dot insert, and I can say that I want to insert, what else is missing here? Say soup. We have some soup, we have rice, we have rolls. Let's say cake. Can insert cake to it, and can look at my recipe sets. Now it has cake added to it. Now let's see how we can actually remove items from sets. So I can say my recipe sets dot remove, and the item that I want to remove is, let's say, veg rolls. And once I run that, I can check if it's removed, and there you go, we have our veg rolls removed from it. What else do we have? There's one more that I want to look at, and that is my recipe sets dot contains, to check if it contains or not. So I'm going to look for fried rice and see what does it come back as. So when I run this, it says true because it has fried rice. What if fried rice? It should probably give me false in this case because that thing doesn't exist. So these are different methods that you can actually run on a particular set. Now there's some special set of operations on Swift that you can run, and those are called as set operations, and these operations are intersection, union, and subtracting. So that, let's say there are two different sets that you have and you want to see what is common in both the sets. You can use intersection for that. What is the common thing in both of them? You can use union. And what subtracting is like, what are the ones that are available in first and not available in second. So let's look at a couple of sets. So I already have one recipe set. I'm going to go down here and then add another one variable my other recipes is also a set, and this set has, so to come up with some things, items, cake, fruit salad, and say lentil soup. Now I have two different sets available here. I'm going to do is I'm going to check the intersection of two of them, both of two sets. So I'm going to say my recipe sets dot intersection, the other sequence, my other recipes. So I'm checking what is intersecting in both of these sets. The thing that comes out to be common in both of them is lentil soup, and that's why it shows lentil soup. Another function that I have is symmetrical difference, my other recipes. This function kind of gives me everything, if you see, except for lentil soup. So it will remove the common things out and then give me the rest of the differencing. So that's called a symmetrical difference. Another one I have, or my recipe sets dot union. So union of two sets. Now when you run this one, you'll probably see it will take the first one and the second one, and it will unite lentil soup. Since it's there, it's going to show you everything including lentil soup too, but it will show it only once. So it creates one single set and gives me those items out. And the last one that I have is my recipe sets dot subtract, and that is my other recipes. So I'm saying take this and subtract this from the first one, and you see we got fried rice and veg rolls because it tried to look for cake, doesn't find it, fruit salad no, lentil soup, and it removes lentil soup from it, and that's why you got two items. So it takes the first one, removes whatever is there in the second one, and then gives you just the first one back. So these are some of the methods that you can perform on sets. Tuples. Swift introduces tuples type, which are nothing but group of multiple types in a single complex type. So it sounds very complex, but it's nothing but you can group bunch of different types together into one single element, and that is tuple. The value in a tuple can be of any type and do not need to be of the same type. So you can have a string and an integer together, you can have integer, double, string together. You can create tuples from as many values as you want and from any number of different data types that you have. So we can look at some examples of tuples. Let's go here. Now if I want to declare a tuple, let's say my meal habits, and I can say that I have 9 o'clock is when I have my breakfast, which consists of let's say eggs, and is it healthy? Yes, it is. So if you see here, what I did is I created a variable with integer, with string, with boolean. So I've had different types into one single object. Now how do I access it? If you look on the right, it says 0, 0.1, 0.2, 0.3, 0.4. It looks like an array, but it's not. You can all say dot 0 and 1, 2, 3. So that's how you can access it. Now if you look at this on the right side, it will give me the value at that particular point. If I say 3, it should give me true. If I say 2, it should give me eggs. So that's how you can access tuple values. Another way of accessing tuple values is by giving them names. So you can give names to them. You can say time. What time did you have? Whatever you have. What did it contain? And was it good? So now instead of using 0, 1, 2, 3, 4, I can say my meal habits dot contain. What did it contain? And you see it says eggs. Was it good? And you can say true. So this is like before. Previously what we used to do was we used to create complex arrays or dictionaries and then put all these different things into one and then pass them around. But now what you can do is you have a new data type called as tuple, and inside that you can group together bunch of different types and pass it along to different places. So that's how tuples are created, and it's very useful in Swift. If-else statements. Let's talk about conditional statements. These statements are used to make decisions based on conditions or variables in code. Let's start with if-else statement. They're the most simplest form of conditional statements. They let you decide based on condition if something is true, this, or do this, or just ignore it. You can also use else along with if to do either this or that based on which condition is met. A little confusing, I know that. You can have multiple if statements to check conditions, or you can use switch. In that case, if you have number of conditions that you can't do multiple ifs. We will learn about switch later in this course. Let's look at some examples for if statements. Okay, I'm going to start with some examples that are more like, that you take decisions on day by day for cooking. Like let's say if I enter the kitchen at noon, I know that I'm cooking lunch. If I enter the kitchen in the evening, I am cooking for dinner. Again, if I am hungry, I will eat, else I will not eat. So based on these conditions, I'll give you some examples. So I'm going to create variable am I hungry. Let's say this is true. Now I can say if, this is how you use am I hungry, then print let's cook, else let's not cook. So since I'm hungry, it will go inside this loop and print this and not the else part. I can just have this statement. This is just using a if statement. If I'm hungry, let's cook. If I'm not hungry, I don't have to do anything, so it will not do anything inside the code. Or I can specifically use else and say print let's not cook. But what if someone else is hungry? Let's say variable is someone else hungry equal to, let's say if this is true, then where does that go? If someone else is hungry and that's true, according to the if condition, that it says let's not cook. But what if I want to feed someone else? So you can also use one more if here. You can say else if is someone else hungry, then let's cook for others, else print let's not cook. So I have multiple conditions here. If am I hungry? I'm not hungry, so I'm going to say no, I'm going to skip this. Else if is someone else hungry? Yes, let's cook for others. But what if someone else is also not hungry? Then it will go inside here the else statement where it says let's not cook. So this is how if else statements work. Now they don't have to be just these variables. You can compare different things. Like I might have a variable time of day equal to, let's say 5 a.m. If time of day is less than 12, print let's get breakfast. Copy this. Else let's get lunch. I can again add one more parameter, again one more case here. If time of day is less than, let's say 16, print let's get lunch. Else the last case is it none of them above, let's get dinner. So what is time of day is 5, so it says let's get breakfast. What if it's 13, just at 1 o'clock? So it says let's get lunch. And what if it's dinner time? It says let's get dinner. So that's how you can actually use if else for multiple cases. It doesn't have to be just true or false directly. It can be a conditional statement that you can use and use your if else statements. Switch statements. When you have multiple possibilities, you can use switch statements. Switch determines based on which condition is met what to execute. These blocks of code are inside a case and will execute based on switch selection. So again, it's like determining what time of day it is and what I will do. So if it's, let's say, morning, I'll probably have breakfast. If it's lunch time, I'll have lunch. If it's evening, I'll have dinner. So switch kind of helps you to determine what to do depending on a particular condition. So let's look at an example we used before using if else statement. Now let's use switch for that. So I'm going to have a playground ready here. I'm going to create a variable, and I'm going to say again time of day equal to, let's say it's 9 in the morning. I can use my switch case here. If I say switch, it automatically populates the rest of the items here. I can say switch, let's say based on time of day. I can give various patterns here. For example, I can say 0. At 0, what to do? At time 0. So it's middle of the night, what do I want to do? Or you can also give a range. I can say from 0 to, let's say, 10. What do I want to do? I want to print, let's move it a little bit above 11. I want to say let's have breakfast. There's also a default where I can say let's not eat. If none of the cases meet, then I'll just say just use this. I can say one more case where I can say, let's say if it's between, okay, I was supposed to say 0 to 11, and here I can say 12 to, let's say, 18, and I want to give one more case. Just copy paste this and populate it later. 19 to 23. So I have 0 to 11, 12 to 18, and then 19 to 23, everything taken care of here. That's lunch, dinner. Now we look at my time. It's 9 a.m. which fits in between this particular case. So it's going to execute this. I can say that if it's, let's say, 2 p.m. that will probably hit this one because it's in between 12 and 18. So it's a let's have lunch. What if it's 7? It says let's have dinner. What if it's 100, which is not possible? There's only 24 hours a day. It's a let's not eat. So it goes inside the default condition. Maybe you've had too much to eat and you can't figure out what time of day it is, and that's how it happens. So switch statement kind of executes depending on what this variable matches with. So you can give anything here. It can be int, string, boolean, whatever it is, and you can create different cases for that particular idea. And that's how switch works. So it kind of goes into a particular case and executes that. It's much more convenient to use than if else statement, because if I have to use if else in this case, I'll have to write if this is true, then do this, else if do this, else if do this, else if do that. So the condition in that case runs through each and every loop and checks, oh, this is true, no, this is true, no, this is true. In this case, it will look time of day, it will directly jump into where it needs to be because these guys don't meet that criteria, and directly executes this. So it's much more easier. For and foreign loops. Now there's nothing called as for loop in Swift 4. It's all for in loops because for loops were removed in Swift 3. But I'm still going to go and show you how for loops work, just in case if you decide to switch to some other programming language and see this, I don't want you to get confused. So I'm going to show you that, but it will not work in Swift. And then there's for in loops. What this helps is for loops is kind of helping you go through a set of items or a range of collection. That's where it helps you. So you might have a range of items or a collection of items like an array. Then you can go through them and then go through each and every item and then kind of use them for some logic and then display items based on that, or do things based on that. So let's look at how we can use these with ranges and with collections. So let me show you first what for loops used to look like. Before that, let's create a variable. I'm going to say meal types, my favorite array. I'm going to create breakfast, lunch, and dinner. So I have 3 different types of meal types. Now if I had to go through each and every item, I would write, you'll probably see this in some other programming languages, where I equal to 0, I is less than, let's say, meal types dot count, because I want this variable I to go from 0, 1 and 2. So that's why I'm saying less than meal types, because meal types dot count in this case is 0, 1 and 2. So so the count is 3. So it will go from 0, 1 and 2. As soon as 3, it will come out of the for loop. And the last one is increment. So I'm saying go from I and keep on incrementing 1 at a time. So if I run this here, or I want to print them, I can always say meal types, and I can specify I in here. So it will go through these statements and print out meal types. Now if you see here, C style statements have been removed in Swift. If you see here, been removed in Swift 3. So you can't actually use this in Swift 3. So how do you write this in Swift 3? I'm going to comment this out, and I'm going to say for item in, or let's say meal, in meal types, what do I want to do? I want to print that particular meal. So if you see, it will print out breakfast, lunch and dinner. So it takes meal in meal types. So for the first one, it will assign meal as breakfast, print it out, go again, is there one more? Yes. Lunch, takes it, goes in there, prints it out, is there one more? Dinner, goes in there, prints it out, is there one more? Nope, nothing, come out. I can write a print here, all done, and it should say breakfast, lunch, dinner and all done at the end of it. So that's how foreign loops work. Now you don't have to give a collection, you can also give a range in here. For example, I can say for item in a particular range, let's say 1 dot 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 to 10, I want to print item. In this case, it will go from, if you see, 1 to 10 and then print out those numbers. I can also use less than 10. So in this case, it will go from 1 to 9 and then stop. So in reverse order, 1.10, but I don't want to go, the range is always forward, so I can say reversed. So it will take a reversed item and then print from 10 to 1. So that's how you can print these things, or use foreign loop for printing or doing anything that you want to do inside here. So you can take a collection of items or a range and then write your statements here based on what you want to do with each and every item. So that's how foreign loop works. While loops perform a set of statements until a particular condition becomes false. So let's say you give a condition to your while loop and say that run this particular set of statements until this statement is not met. For example, while I am hungry, keep on eating, keep on eating, keep on eating. After some time, am I still hungry? Yes, I am. Keep on eating, keep on eating, keep on eating. Or am I still hungry? No, I'm not. Okay, let's stop this statement. So that's how while statement or while loops kind of work. There's another one where it's called as repeat while. What repeat while does is it will run the set of statements at least once. For example, I'll say, okay, you eat this. And are you full? No, eat this. Are you full? Eat this. So eat this is my statement. It will say keep on eating, keep on eating. And then it will check, oh, are you full? Are you full? And when you say yes, okay, that's when it will stop. So these statements are kind of risky to use sometimes, because if you forget to increment or ask in between, like, are you hungry, or do you still want to eat? that's when it kind of becomes messy and it keeps on running forever and ever, and it might crash your application. So it's always good to kind of make sure that you give your condition before you kind of write your print statements or do anything. So let's look at our example. Let's create a playground. I already created one. I'm going to say where time of day equal to, let's say it's midnight, while time of day is less than 10, what I want to do is I want to say time of day plus equal to 1. So I'm incrementing the time of day by 1. What will happen is this will run it 10 times as it shows here. So let's print it out. Are you hungry? So it's going to type are you hungry at, let's say, time of day. So it's going to keep on asking are you hungry at 0, 1, 2, 3, and as soon as the time becomes 10 it will not go inside this, and that's why you don't see it printed. But what is the value of time of day by the end when you come out of here? If you see, it already incremented it here, so the value of that time of day is 10. So it goes from 0, 1, 2, 3, 4, so 10 times. At the end of it the value of time of day is 10. So I'll keep that here just to see. Now let's look at repeat statement. Inside repeat statement, it's like I'm going to time of day minus equal to 1. So I'm going to reduce the time, and I'm going to ask here while, keep running this statement, while I is, let's say, greater than 0. So I'm kind of repeating, I'm going in the opposite direction. Here I can say are you hungry, time of the day, sorry, not what I meant was time of day is greater than 0. So what I'm doing here is like first I go all the way till 9. The value of time of day is now when you come out of here is 10. So it's going to go inside and do that without doing anything. So it's a, are you hungry at 10, and then it will reduce the time by 1. So now it's 9. Is time of day greater than 0? 9 is greater than 0. So it's going to go keep on repeating it, and when it goes at the last, it says when the value of time of day is 1, it says 1, reduces by 1, so it becomes 0. Time of day greater than 0, is 0 greater than 0? No, so it comes out of it. So that's how while and repeat while loop works. Swift optionals. Optionals are a powerful feature in Swift language which helps you with non-existing values, meaning nil values. Optional is just like any other type in Swift language. Think about string and string question mark, also called as optional string, which are two different types. If your variable is of the type string, you know it will always have a string in it. And if your variable is of this type string question mark or optional string, it will either have a string value or it will have no value at all. In other words, it will be nil. Think of optional as a box of cookies. This box of cookies might have cookies in it or maybe not. That's why the question mark at the end. I know it's a terrible thing to have no cookies, but example, it happens. Under the hood, optional types are just enums with two cases. None, meaning no value is set, and some, meaning the value is set and its value associated with it. Let's look at some optional examples. I already created a project, a playground. Can't call it a project. Swift optionals. So I'm going to go here and create a variable number of cookies. Now if I set something like this, you're used to it, you can give a value 20, but if you want to make it optional, you can do something like this, and it's optional, and you'll see that the value is nil to it. If I remove the question mark, it's still, if you see, it's nil, but this will help you in future kind of to set the values or tell you what it does. So I'll kind of go over it. So I'm going to give a value of 20. I'm going to create one more. I'm going to call it name of cookie. Inside this, I'm going to make it of the type string question mark. So this is how you create optionals. Now let's print something so I can show you how optionals are helpful. We have number of cookies of type, and I'm gonna say name of cookie. So now when you print it out, you'll say we have optional 20 cookies of type nil. Since this value is nil, it's showing you nil over there. If I remove this, if you don't set it as, it will give you an error. So you get a runtime error, right, or compile time error right over here, saying that, oh, you're trying to display something which is nil. Are you sure? Because it needs to have a value. So by creating it optional, you can actually have it as a nil and still have that variable available. But the problem here that you see is the optional 20. So what's happening here is it's printing optional 20 because it's a variable inside a wrapper, just so that the application doesn't crash. We will learn in the next video of how to unwrap these wrappers. I hope you will see the importance of these optional types. So what happens is, the reason it's optional 20 is because it's actually a box of cookies, or let's say this is a cookie which is wrapped inside a particular optional. So it's a box. So we'll see how to open the box and get the value out of it, open this box and get the value out of it in the next chapter. So that's about optionals. Unwrapping optionals. So how do we unwrap optionals? In the previous chapter, we saw that how we can create optionals, or in this case, I would say we kind of protected a variable by putting optional property to it. So how do we unwrap these optionals that we created? We saw how it prints out, it says optional 20, and that's not what we want to display to the user. So because compiler doesn't know how to add a box into a type or remove it for that matter, in order to achieve this, we need to unwrap the optional. In other words, we need to open the box and extract the value inside. For that, we put the bang mark or exclamation mark after the variable's name meaning. So what I mean is, I'm sure this box contains something. Extract that value and use it. So that's what exclamation means. So in that case, you are actually force unwrapping, or you're forcing it to give the value. So it's generally a very dangerous thing to do that, because the box is empty. Because the box is empty, the app will crash at runtime. So it's more like, you're trying to give a box of cookies to a kid, and when you're force unwrapping, you're saying that there are cookies inside it. Whereas if there's no cookies, the kid will just start out crying. So that's more like an example with this. So when you're forced unwrapping, you have to be very careful that it has a value, or else your app will crash. A good practice is to check for nil before unwrapping. Let's look at an example from a previous project that we created, or playground that we created. So this is what we had, and we saw that we have optional 20. Now one way of doing it is forced unwrapping. You just do this, and you'll see, there you go, we have our number of cookies displayed properly. So that's how you forced unwrap things. But why don't we always forced unwrap? Like, for example, this guy is showing me nil here. If I forced unwrap this one, it's gonna, so if you see here, there you go, error, unexpectedly found nil, because you're trying to force unwrap this variable and it is nil, and it's gonna crash your application. So that's not a good practice to use forced unwrapping unless you're 100% sure that there is something. For this variable, we will have to check if the value is nil, and can't use forced unwrapping since it will crash. So optional binding is another way of opening the box. It allows to check the optional and get its value into a constant or variable as part of the single action. So we'll see how to do that. It's useful when we need to use, say, the unwrapped value many times in the if body. So let's look at how we can do this. I'm gonna comment this out just to compare at the same time. So I'm gonna say if let, this is how you kind of do optional binding. So I'm gonna say here, so if let, and I can create the cookie and give it name of the cookie. So what I'm doing is, if let, what it does is it creates a variable, so it creates a constant in this case and assigns the value of here, this to this. So if this value exists, then what do I want to do? So I'm going to go here and I can print this variable, this entire line here. So that means that I have, so instead of this I can use this now because that's the value there. So I'm saying if the value exists, I want to do this, else since I don't want to display nil, I can just tell them that we have, so since only this value is there, it's going to go inside this and then unwrap the value and say we have 20 cookies. But if I assign it, say I have awesome cookies, if I can spell that right, okay, awesome cookies. So now it will go inside this one. It says print we have 20 cookies of type awesome. Or if I don't have this, it will just skip that first line and go to the second one, and it will display how many cookies we have. Here we didn't use the exclamation mark after this. That's because it represents that the already unwrapped value is what we're using, which is the cookie. So we just unwrap it once and we can use it multiple times in the if body. So if you see here in this one, we have done it because we didn't unwrap that. We can kind of use the same thing for this guy too, but that's how you can do two different things: forced unwrapping or optional binding using this if-let condition. Chaining optionals or optional chaining. Optional chaining is a feature that allows to call properties and methods on an optional that might currently be nil. It's like asking our cookie from previous example if you are crunchy or not. If the cookie doesn't exist in the first place, forced unwrapping will result in a runtime exception, whereas optional chaining fails gracefully when the cookie is nil. Let's take another example. You may or may not have breakfast today, but breakfast does have food in there. So if we want to check what is the food options available for breakfast, we might need to first check if you will have breakfast or not. And in case you do, we can also figure out food options. Here's where optional chaining and the idea of using the wrapper without opening it comes into action. Let's look at this example in action. So I know that we have not created any classes yet or learned about Swift classes, but for the sake of this example, we'll be using classes here. Classes are just representation of items we are using in our code. We can probably, or you can visit back this course after we finish class, but class just kind of is a blueprint. So let's try and create a person. I'm going to keep it as simple as possible with classes just because we have not covered it yet. Now this person has a property inside it called as breakfast, and I can say that this breakfast is not a string or not anything, but it's of the type class. So you can have one class belong to another class, and that breakfast class is coming up right here, breakfast class. So this is how you can create breakfast, and this person has breakfast object which is this class. So you think of it as if this is the class string that was created by Apple and you're using it, same thing is happening here, and I'm creating this breakfast as optional. Now I can set food options. So what all different food options does my breakfast have? So, or how many of them do we have? Just to keep it simple, I'm going to keep it int type. I can give it optional value too, but what I'm going to do is I'm going to say that this has 0 food options by default. So that's how I'm going to set it. So I have two classes. One class is breakfast class, which has a property food options, and it says it has 0 food options by default. So if you create a class or a variable of the type breakfast class, it has 0 food options by default unless you set something. And then person has a property of breakfast which might be a value or might not be a value, is nil in that case. So that's why it's optional here. So let's go ahead and create an object of the type person. So I'm creating a constant and I'm saying this constant is person. This is how you can create a new object of a particular class by saying the name of the class and brackets around it. So this creates an object of this particular class. Next, I'm going to say if let, that we used last time, food options. So I'm saying let's look at food options. And food options comes from, so if you see here, I'm going to say person, which I know is a object, so it is not a nil. I'll say what is the breakfast that you have. Now if you see in this case, this value can be a value or not a value, so I'm going to put a question mark, and then I can say food options. So this is how I can get food options. So what will happen is, first it will check, we know that the person object exists, so it's not going to crash here, or else if this was an optional too, we could have put that. I'm saying dot breakfast, so I'm checking if person has a property breakfast. It might have a value, might not have a value. If it doesn't have a value, it will just quit right there. But if it does have a value, it will check, oh, what are the different, how many food options does this breakfast have? So that's what happens here. So I'm going to go ahead and print something. Say person has food option. Just to not confuse it, I'm going to say how many food options. Person has how many food options for breakfast. So if it has a number, it will give me that number. Now in this case, it will not print out anything. The reason being, as soon as it checks person, does this person have any breakfast or not? It didn't have a breakfast, so it's going to just stop here and then quit out of it. So I can just say else person didn't have breakfast. Sad face. So if you see, person didn't have breakfast, sad face, that thing came out because as soon as it went here, it said, oh, this person didn't have breakfast. So it didn't even go into the optional chaining, the second part of it. So what I can do is, I can say person did have breakfast, and to do that, to give it a value, I can say, can create an object of this. This is one way of doing it. Another method of doing it is, you can create an object of type breakfast, and I can say this person had this breakfast. So there are a bunch of different, either use the shortcut or define all your variables properly, and just in case if you want to use it. So if you see here, person has 0 options for breakfast because it always has a value, so it doesn't matter. But the previous case, there was no breakfast object itself, so it didn't even have breakfast, so it did not even go inside the food options. This time it had person, it had breakfast, so it goes one at a time, and then as soon as it reaches here, so it kind of, if something is not working properly, it will gracefully exit and go into the next object. I can also set and say here breakfast dot food options equal to, let's say we give the person 20 different options, so it says person has 20 options for breakfast, because we are setting a property of the breakfast food options to 20, so it will override this 0 and set 20. So that's how optional chaining or chaining optionals is helpful, where you can kind of go at each object at a time and then see if that exists or not. So that's how optional chaining works. Next we'll look at guard statements. Guard statement. You can think of guard statement as if statements with an attitude. Like an if statement, guard executes statements based on a boolean value of an expression. Unlike an if statement, guard statements only run if the conditions are not met. You can think of guard more like an assert, but rather than crashing, you can gracefully exit in this case. In case of guard statement, if the condition passes, the optional variable is automatically unwrapped for you, which within the scope that the guard statement was called. So it kind of automatically unwraps the value and gives it to you, just like if-let that we've used before. Guard statements are very handy for error handling in long run by setting up requirements in your code and making sure that you don't have any unforeseen errors down the line. So it kind of helps you more like a test-driven development kind of environment. And guard statements, and I mentioned, it does unwrap optionals much like if-let. The only problem with if-let is if you kind of chain options over and over again, there is a problem called as pyramid chaining, where you have a pyramid of doom, where you can do if let over and over object. If it's a deep object, you kind of keep on doing that, and you can get into trouble. So that's where guard statements are more handy, because guard statement lets you decide if it returns, so it will let you gracefully exit if it doesn't exist, and you don't have to go inside. Whereas if let, you have to kind of dig into it one after another just to see if the optional value exists or doesn't exist. So let's look at an example. I created a playground, and we're going to use functions. We have not done functions yet, but let's add a code inside a function here just to see how it works. So usually functions are set of commands that are written together, or set of code lines that are written together, grouped together in one particular place. So I can show you the basic definition of function. So I can create do something function here, how you create a function, and we'll learn it in the next section. And to call this, all I have to do is, this is how you call this function. So usually this function will not run if you don't call this function. So inside this, let's say I can say hello world, and it will print hello world because I've called it. If I don't do anything, it will not print out anything here. 1 2 and come on. Okay, so if you see, doesn't print anything. But when I call it, so let's say this function do something function has a variable meal, which I'm not sure that exists or not, so I'm going to create it as optional, and I'm going to give it a value. Let's not give it a value. Let's say it's nil. I can use a guard statement here and say let the meal equal to meal else. So if you see, in this case, you give the else before, and you go inside this else case if this meal doesn't exist. Whereas in if let, you go if the value exists. So here I can say print no meal, and then I can just return out. This is how you get out of the function. And if it does, if the meal exists, I can just say print the meal. So if you see, the variable also exists afterwards. Whereas in the case of if let, the variable doesn't exist outside the if let. The scope of the variable is just inside where you say if I say if let, the scope is just there. Whereas in guard, the scope of this variable is outside and not inside. It will go inside this only when it crashes. So you can think of something like if let a equal to b, and then you say if let, and you keep on going. So this is, if you look at it sideways, it becomes a pyramid of doom. So that's why it's called pyramid of doom. Now in this case, since it doesn't have anything, so it says oops no meal. But if I give a variable to it, I can say I'm gonna have a breakfast. So now it will not go inside this else statement. It will jump outside and go in here and display the print. So since it's giving me a warning here, since this was never mutated, never changed, so I can always give it a constant, and it will not give me that warning too. So there you go. That's how guard statements help you from writing bad code and have a better, it will not crash your application if some variables are nil. So you kind of do a check, or you guard the particular object that you're using. And that's it for guards. Basic Swift functions. Functions are a named section of a program that performs a specific thing. In this case, a function is type of a procedure or a routine. Swift comes with a set of functions that are already returned for us as a part of the language. For example, print is a function which also takes an argument of what you should print in it. So that's what we've been using quite a lot in previous tutorials. Anyway, you can compare functions with tasks while cooking. Preheating the oven is a function while baking something, or heating the oil, cutting vegetables. These can all be a bunch of functions during the process of cooking. Cooking itself can be a major function, having all these small functions inside it. Let's look at some examples so we can understand this better. Let me start a project. Just a new playground. Next, I'm going to call this one, let's say, functions. Save this file. Let's start with let's say a basic function. Okay, so let's start with function get eggs. This can be a function which can do, for example, so this is how you can kind of write a function where the name of the function, or you kind of tell the compiler that it's a function by typing func and then space and the name of the function get eggs, and then open close brackets. Inside these open close brackets you can pass parameters, and also after that you can give something called a return type, which we'll see in a little while. We'll see that what it looks like. Now I can call other functions, or I can do some things here, like I can say I can define a variable x equal to, let's say 10, variable y equal to 20, and then I can say variable time to get x equal to 10, or x multiplied by y. So this is a way of doing it. Other than that, I can also call other functions inside this. For example, I can call print, which is a predefined function. I can say, let's say open the fridge. Next I can say, so get eggs, the process is open the fridge, look for eggs if you can find it, and next is bring them out to the counter. Right, so that's how you can get eggs. So this is a function which tells you how to get eggs. So that's a basic example. Look at another one. Let's see how you call, but one thing that we missed is how do we call this function, or how do you initiate this function. All you can do is just type the name of the function get eggs, and you'll see it kind of runs the function for you, and that's how you run a function, or call a function. Let's see a function with a return type. So I can say function what's for breakfast, and this guy returns, and this is how you specify what does it return. It returns, let's say, a string. So this is how, using an arrow, you can say what does this function return. It's going to give you an error because saying this function doesn't return anything. Let's say return, since we are getting eggs, let's return omelette. Okay, and how do I call this? Let's say, well, first meal what's for breakfast. So what it does is it calls this functions, gets a string back which is omelette, and it will specify, okay, spelling mistake, and it will take this omelette and assign it to this guy. If you see here on the right side, you see that there is omelette that is returned by this first meal object or variable. Let's look at another function. So I can create function with parameters. This time I'm going to say preheat oven to, and I can pass a variable inside. I'm going to pass int in this case, and I'm going to say preheat the oven to a particular temperature, and inside this a function to kind of preheating an oven. And I can actually return something, but to return something you'll probably have to make sure that returns a string. And I'm going to say return oven preheated to the temperature that was sent to me. I can call this function. Let's call this function. I can just say print, and inside, so I can nest functions too. I can put a function inside a function. So I can say preheat oven to, let's say, 100 Fahrenheit, and if you see this, it will call this function. It will take this temperature 100, assign it to this temperature variable, and when it's returning it, it will return it over oven preheated to this temperature, and that's what is printed out here. So that's the entire process when it runs. So the compiler will come here, it will say, okay, print. I have to print. What do I have to print? Nothing to print. Is there's a function here, so it's going to call the function, pass the value 100. It says, oh, what is the return string? It does whatever it does here, and then gives back oven preheated to this particular temperature that is passed, which is 100 in this case, and that's what we get back. Now we can have more than one parameters in here, so I can always give one more. I can say after interval int. So now I have to pass back another thing after interval, let's say 5. So I can say oven heated after waiting for after interval minutes. So now again it will call this function, it will pass 105 as parameters to this particular function. It will take these and then it will return back oven preheated to whatever temperature was for after waiting for whatever time was passed here. So if you see oven preheated to 100 after waiting for 5 minutes, it will print out that value for you. Now you can also use something called as default values in here. I can specify that if nobody gives me a value, it will use 4, which means that I can call this function without this second parameter, and it will call it and it will use this predefined value which is 4 or default value as 4 and use that inside here. So if you see here, oven preheated to 100 after waiting for 4 minutes, and if I want to override that, I can just a random number. So this value, if it has a value, it will overwrite this 4 and take 19, but you can add default values to it. So that's how kind of function works. You saw how a simple function works. We saw the return types. You saw how to pass arguments to a particular function and make it more complicated. You can do like some simple arithmetic operations. You can say add two numbers and pass two numbers, multiply two numbers, and bunch of different things. Or you can use something called as generics, which you'll probably learn in future. Advanced Swift functions. Unlike some other programming languages, Swift has some advanced functions which you will never come across in other programming languages, like returning multiple return types from functions, returning optionals from functions. I mean, it's sometimes handy to have return multiple things from particular functions. You don't just want a string, you want a string with a boolean or string int and boolean. So we can use tuples here to return multiple items in the functions. Also, you can use optionals, which you can return some value, or maybe if you didn't get a value inside the function, nothing happened inside the function, and you want to return a nil object, so you can do that inside a function. So that's what we'll look at in this particular section. Let's go and start a Xcode project or a playground. Call it advanced functions. Let's start with delete everything and start with function is the food ready, and I want to pass by what meal am I looking for. Pass it string. So this is going to return back if it's ready or not, which is a bool, and it's going to return back a value which is a string. So if you see in this particular function, we have two items that are being returned back instead of one item that returns. So we have a bool value and a string value that is returned back to us. So I can say, let's write some logic. If what meal equal to lunch, and that's the argument that I'm passing here. So if lunch was passed, I'm going to say return lunch is ready. So I have to pass back a value, a tuple with boolean and string. I can say what is available, what is ready. So I'm going to say veg fried rice. That's what is available. Else I can also look for, let's say, what meal is dinner. Then I can say yes, it's not ready, and what you'll have is lentil soup. Like to my functions properly. Okay, so that's what I can also pass back. If nothing is available or nothing is ready, I can say everything is ready, and that's in this case if it doesn't hit lunch or dinner. Let's say they looked for breakfast, and I'm going to say grilled cheese sandwich is what is available right now, so you can have that. So how do I call this? Let's see, my option equal to is the food ready, and I'm looking for, let's say, lunch. It's going to give me back, if you see here, the lunch is ready and I have veg fried rice. You can also print this out if you like the printed option of it. Your meal is ready. Let's say if my option dot, let's say ready, because it has two parameters, ready and value. So if I'm saying if my option is available, I want to print your meal is ready, you will get to eat. What am I getting? My option dot value. So if you see your meal is ready, you will get to eat veg fried rice. That's what it returns back. I can also say else your meal is not ready if it returns back false in this case, and what do you get to eat? So if I say I want to go dinner, and it will say your meal is not ready, you will get to eat lentil soup. If I say okay, what about breakfast? So it will say your meal is ready because breakfast returns back this, and then it says you'll get to eat. I can pass anything here and it's gonna call this third function no matter what I call it, because if I lunch and dinner it will go into this if loop, but if not I'll get this return. I'll hit this return statement and that's what I will get back. Let's look at some more functions. I can use so that's how you can return back tuples. You can have 2, 3, 4, 5, whatever number you want. Let's look at optionals, how we can return back optionals. Say func do you like my and food item string, and it's going to return back, let's say true or false, but it might return back nil too, if it doesn't work out, if you don't want to answer. Sometimes someone asks you, hey, do you like my fried rice that I cooked for you? Sometimes they say yes, sometimes they no, and sometimes you know what the answer is but they'll not answer anything, so that's return nil, let's say. So I can specify in this if, let's say, food item equal to, someone asked about fried rice, I can say return true, and let's say if I cook really good fried rice, and if I say egg salad, horrible, so I can say false in this case, and if something else, don't know to cook anything else, so I can say return nil. So this function can return me true, false or nil. That's why I have an optional value at the end of this. I have the question mark right next to it because it can return nil. So I can say if let, so I can use our unwrapping skills that we learned before, do you like it variable, and I can say do you like my, let's say, egg salad, and as soon as I pass this I can say print, I can say you liked my, let's say I just copy this egg salad, and the value that was returned back was do you like it. So when I pass this is what I'm gonna get. So if you see, since I passed egg salad, it will say you liked my egg salad was false, or I can say that did you like my fried rice, and it will say okay, it takes some time, you liked my, oh sorry, I had to fried rice, and it will say true, yeah, you like my fried rice, because it's gonna hit this. But what if I pass, let's say do you like my rice, and it's not gonna print out anything. This is the second print which is here. I'm gonna just comment this out, and now you'll see it will not print out anything here because it doesn't know. So for that nil option, because if let, and if this is nil, it's not going to go inside, so we'll have to print something else out and say something. You don't like my cooking. Well, something that's my normal response if nobody answers my question. So I say something. You don't like my cooking. So that's what will be returned back if we get nil from this particular function. So that's how you can write functions with multiple return types and with optionals. Swift function types. Function type is a unique style of signature of a function. Function types can be used just like any other types where we have seen before, like before we have passed in integer, boolean or string. So this is very useful when you pass functions into other functions as parameters or use them as return types of other functions. Let's look at some examples to kind of understand how this works. So you can kind of add like functions inside functions, meaning you tell that I need, so let's say cooking is a function. Inside that you can pass other functions like preheating the oven or doing more things inside it. So it kind of makes your code clean. So let's look at an example. Can start with, call it function types, delete everything that is in here. I'm going to say function cook for how long, and it's going to pass me time in hours. I'm going to say integer, and I'm going to return back integer in this case, where I'm going to convert this hours into, let's say, minutes. So I can say time in hours multiply by 60. That will give me how many minutes I have to cook for. Now let's say if I have another function, let's say cook, and inside this what am I cooking? String, and for how long, for time, which is int, and next parameter I want to do is which function do you want to use, using func, can say, and this one, so you have to specify the style of this. The argument that this guy takes is integer, return integer. So that's how you kind of specify how the signature of that function is. Here, there you go. That's where we write our function. Let me see if I close this. A lot of times I forget to close these functions. Okay, there you go. I have that. Let the function type equal to using func for time. So what I'm doing here is I'm calling this function, I'm saying that using function, which is this one, and I'm passing the time that I get here. So this will call this function and give me the value inside here. So once I have that, let's print this out. Print cook. Let's see if it works. What item am I cooking? Let's cook item for, what was the time that was specified? For time. Now this time was in hours, that's what I mentioned. Or let's say the function time, what will it have? It will have the time converted into minutes. So I'm going to just say minutes here. Let's call this function and see if it actually works. I'm going to say cook item fried rice for time, let's say 1 hour, using function. Which function do I want to use? So in this case I can just give the name of the function. You don't have to specify the arguments because arguments are passed using this parameters here, so you don't have to pass it. And if you see this, it said cooked fried rice for 1 hour or 60 minutes. So it actually went inside and it said the function that I want to use, which is this one, replace this with this here, cook for how long, and it calls this function, converts my time into hours into minutes and gives it to this function, and that's how it works. So function types are very easy to use and kind of makes your code look much more cleaner. Overloading Swift functions. Overloading functions is having multiple functions with the same name as long as their function type, or let's say signature, is different. It's like you have the same function called as cook, but depends on what you pass or what you don't pass, it might do different things. For example, you can say, oh, cook me pasta, or you can say cook me fried rice for 20 minutes. So cook pasta is a different function from cook fried rice for 20 minutes, because first function you're passing only one parameter, in the second one you're passing two parameters. So let's see how you can overload multiple functions or overload functions in Swift. Let's see some functions of cooking in different ways using overloading. Let's see, let's start a new project. I've already created a new file, and here what I'm going to do is I'm going to have a function. So I'll have a function called as cook function, and this cook function will print I am cooking something awesome. Something awesome. Now I can have a same function. So if you see here, if the signature is same, it's going to give me an error, and when I call this function, it will not know what to do, or maybe cause some problems. So what I'm going to do is I'm going to say this second function takes a parameter, and that is of the type string, and here I can say I want to print I am cooking this item. And so these are two different functions, even though they look same, because that's what is overloading. Now you're using the same function name, but you are passing an argument here. So I can say rice, and you'll see it will call, first one will call the first function, second one will call the second function. Okay, I think I forgot this. There you go. Cook item fried rice, and we'll have I'm cooking something awesome, and I'm cooking fried rice, which is called by this one. I can pass some, so let's say the soup, and for what, and I'm gonna say want lentil soup for dinner. Now this is a different function, it doesn't have it, so it's going to give me an error saying that this function doesn't exist. So I can kind of use that signature and then extend it or override it, saying needs another string for what, and inside this you can say I'm cooking item for what, and now I'll have this function call this particular function. So this call is going to this guy, this call is going to this guy, and this call is going to this guy. So this is how you can actually write a function with the same name but different signatures of what you're sending it. You can also write your own, like you can pass functions to functions inside them and then have it more looped, like what we learned in the previous lesson. But that's how you can overload functions. The closures. Closures are self-contained piece of code that can be passed around and used in your code. So they are like small pieces of code that are much helpful. Closures can capture and store references to any constants or variable from the context in which they're defined. This is known as closing over those variables. That's why they're called closures. If you're interested in developing iOS or Mac applications, you know that you should know what closures are, because they're used so much in Cocoa framework, which is the integral part of making applications. Think of closures as something you prepared and kept ready for the cooking process. Think about the task of slicing onions and keeping it ready so you can use it as soon as the pan is ready and hot. Or you can think of having some spices and herbs cooked separately and kept so you can add it to your meat or vegetables whenever it's ready. So let's look at some examples so you can understand closures better. I'm going to start with a project. I've already created a file. I'm going to call it. Let's start with the understanding how an empty closure looks like. So I can say variable my ready to cook recipe. Now this closure usually takes something called as parameters, just like functions. It takes parameters, or it can be empty, and it can return something back, and the body of the closure is written right after this. So this is what we call as an empty closure. It doesn't do anything in this case. It doesn't take any parameters, it doesn't return anything, and it doesn't do anything inside this. So this is an empty closure. I can create a closure, let's say cook my food, and inside this, if it doesn't have like inside this I can kind of go on the other side of the declaration of the closure, and inside here pass my, let's say, parameters item string, and then what does it return? Let's say it doesn't return anything. Can set void, and then in. So in is used, this is kind of a way to divide your declaration and whatever follows in the body of the closure. So you can write your body after this, so whatever follows after in is part of the body of the closure. So I can say print we cooked /item. So this is how you can write a closure. There's a shorthand version of it too, but this is how you can define. So I created a closure called as cook my food, and if on the other side is the actual definition along with the parameters that it takes and the return type. So my variable is going to call a closure. This is actually an anonymous closure, you can think of it as, because left hand side I'm doing something and giving it to my right hand side. So it's more like calling a function, but this function doesn't have a name. And so what I'm doing here is I'm saying that this particular function or a closure, it takes this as the input parameter, this is the return type, and it's gonna do this. So if I call this cook my food and I pass, let's say, fried rice, it's just called like a function, and you'll see the output we cooked fried rice because it calls this variable, passes this fried rice inside here as item, and then that's how you get it. There's a shorthand for writing closures. I can say, let's say, cook fast. It's gonna take string as the parameter, return back a string, and inside this I can say item, that is my item, which is what is passed in here. In I can pass back return, since it needs a return. This time I'm not gonna pass anything. We cooked item fast. So this is a shorthand method of writing the similar function up here, where I'm kind of adding everything on the left hand side. I'm saying this is the parameter that it takes, or argument that it takes, and this is the return type, and this is what actually happens. So this item is replaced by this string here that it gets as parameter, and it takes this and then returns back here. So I can call this similarly and say cook fast, and I can pass lentil soup, and you'll see nothing will be printed out here because I'm returning something back to this guy, and you'll see that item here, we cooked lentil soup fast, because if I assign it to something, since it's returned back, I can print that item out. So, or I can just do is, I can say print, then pass it inside here. Let me just comment this out, and now you'll see this method being called, and there you go. If you want to keep this up, you'll see both the print statements, cooked fried rice here, and using the shorthand method we cook this here. So let's see how can closures be used as function parameters. This is where it's kind of becomes very handy and very useful. So I can just say, let me create a function, what am I eating today, what am I eating today, and I'm gonna pass a menus array of string, and this is to pass it as a closure here. And so I'm saying I'm calling a menus string, but the parameter that it takes is more of a closure. So let's select meals equal to, and say breakfast, lunch, and dinner. So I have 3 items. Then I can say menus, which is this closure here, and I'm going to pass it meals. And now this function I can call him like this. So if you see here, what happened is this function is expecting menus, which is a closure. So when I go here and I'm saying what am I eating today, so if you see here it's expecting more of a closure. So if you look at the declaration here, it's exactly the same type. What I can do is I can directly call this function using this way and say that meals, whatever is passed to this here, in for meal in meals, I can say print meal, and that is my meal that is passed to this particular object. And I can, if you see here, breakfast, lunch and dinner is printed out. So what happens is this is a much nicer way of following. So you can write your function in one place and then have the closure call defined somewhere and then execute this particular item. So this is kind of a very neat way of writing things, and closures are mostly kind of saved in stack memory, unlike functions which are in heap memory. So it takes much more time in functions, whereas stack memory, as you know, is much more faster. So closures are much more faster than functions. Swift type alias. Type alias allows you to provide a new name for an existing type into your program. For example, you can call a string a potato or call int a banana. But why would you do that? Maybe it makes sense in the code that you're working with. After a type alias is declared, the alias name can be used instead of existing type throughout the program. Don't misunderstand that type alias is to create new types. They simply provide a new name to an existing type. The main purpose of type alias is to make our code more readable and clearer in context for human understanding, or other programmers. They can look at it and kind of tell you that, oh, this is what it means. So let's look at some examples of how type aliases can be written. Let me create a new project, and let's say I say my name. So if you want to create a my name variable, you can pass it, say your name, and this will work perfectly fine. Now using type alias, I can say that the existing string type, which was called, I usually like to keep it was string, I mean something that was string before is now called was string. So I can say my full name was string equal to, so if you see here, instead of using string, now I can use was string. If this doesn't exist, it will give me an error, but this is how you can use aliases, type aliases, in a simplest form of manner. I can do is I can say type alias my capital my awesome tuple, which contains int, string and boolean. So I have three different types. Now I can, instead of defining it this way, I can just say my awesome tuple, and that kind of saves me a lot of times. If I keep on using this again and again, it makes more sense. So I can say variable the awesome variable equal or is of the type my awesome tuple, and this guy takes in, let's say 30, the time that I need to cook. I'm cooking, let's say fried rice again, and has value 3, true. So this doesn't make any sense here, because what am I doing inside this particular? So you can also give some arguments to this, or parameterize it, like you can say time, name, and is, let's say, is available, and I can have some. So it's in a restaurant, you can, how much time does it take to get fried rice, and is it available here? So something like that. You can add it in my awesome tuple, or is this food available and at what time? Okay, I'm not gonna come up with anything, I'll just keep it as it is. Next, I can let me think of more things. So you can also do this with closures, something that we learned recently. I can say type alias, you can say awesome closure, and you can say that this awesome closure is of the signature string or a string array, which returns back nothing. So now your closures will look much more prettier than what they look in normal cases. Called as let's say what's special, and this guy takes my awesome tuple as a reply, returns back awesome tuple, and inside here I can just say return 30 fried rice and true. This kind of goes back to the previous. So what's special, and I can return this back. Inside this function the return type is my awesome tuple, which is this guy, and I can say print what's special, and it will print out this particular item. Now I can say what's special dot time dot name and kind of write it in a different way, or I can use that the closure. I can just say get menu items, and the closure that I want to pass is of the signature awesome closure. So I don't have to use that ugly style anymore with arrows, brackets, this, that. I can just use something simpler as awesome closure, and inside here I can say items equal to, let's see what was on my menu, fried rice as usual, have lentil soup, and I have veg rolls. Oops. Okay, veg rolls. These are 3 items that I have. Then I can pass these items to the closure that will call it, and whenever I want to use it, I can say get menu items, and here I can say food items in for item in food items. I can just say print the item, print item, and that should work perfectly. So if you see, the first one was this one using the type alias as function return type, whereas in this case I have my items where I'm passing it over here, and it will return back my items one at a time. So that's how kind of closures work, and that's how you can use them with type aliases. Type aliases is pretty awesome, especially when you want to give a better styles or naming conventions or existing styles, or in case of closures where you want to make them look pretty. So that's how type aliases can be used. Basic classes. Classes in Swift 4 are one of the building blocks. Just like constants, variables, and functions, the user can define classes and their properties and methods. Classes are just like recipes. You can see them, you can read them, but you can't eat them. They are the blueprints for the actual food, which in programming world is also called as objects. So classes are nothing but blueprints of the objects that you create using these classes. It's just a symbolic representation of objects that you would need. So you would probably architect the entire blueprint and then provide it to your code so they can actually use it. Swift allows us to create classes as a single file, and the external interfaces will be created by default once the classes are initialized. You can also create classes as subclasses of other existing classes, which means you can take a recipe and then create your own recipe by adding more steps to it. You do not have to recreate a recipe that has already been created, and we'll look at subclassing a little bit in further. One important thing to remember about classes is the objects created are class by reference, which means pass by reference, which means when you pass objects to other objects, you're passing a reference to the location of the object and not the actual value. Let's create some recipes. Let's create some classes. Let's go open Xcode, and I'm going to start a playground and call it classes. And remove everything over here. Now class with, as I said, let's create some recipes. Let's create a class recipe and give some things like name of the recipe, which is a string, can associate number, the amount of time to cook this recipe is probably int, and variable time already spent cooking this recipe. We'll also keep track of that. I'm going to set that as int. And you can also have some predefined values, like for example maximum spice level, which is integer, and I can give it some value as soon as I initialize it as 5, let's say 125, 5 being spicy. Now if you see there, it says class recipe has no initializers, so by default you'll have to provide some type of initializer for this particular class. Classes needs initializers, structs don't, and we'll look at structs later, but classes do need initializers. So I'm going to create an initializer, and the parameters that we need are the parameters that are passed. So I'm going to give name, say string, so whatever we have on the top, time to cook is int, and time taken again in int. So I provided these. You don't have to provide this because it's already been initialized, so you don't have to kind of initialize values which don't require, which are already available. So I'm going to say name equal to name, whatever is passed to me, self dot time to cook equal to time to cook, self dot time taken equal to time taken. So that's kind of gets all my values in place. Now there's also convenience initializers. This is the kind of delegated initializer which you need to be there. So every single class has a default initializer which needs to be there, and that's this initializer. And I can provide my own convenience, which kind of helps me while I am initializing some objects and some values are default. For example, I can create an initializer with name and time to cook as requirements, and then I can just say call the init method, and I can pass the name that I got, cook, time to cook that I got, and default I would say every single thing that or time taken is initially 0, because when you start a recipe you not started anything, so time 0. So I can set something like this, which might be very helpful while you are coding something. Other than that, we also have computed properties. So we can have a computed property. For example, I can say time remaining to cook can be of the type int, which can be more like time remaining to cook is time to cook minus time already taken. So this is something that we can compute in here, so that makes more sense in here. Other than that, we can also have something with with properties which have getters and setters already been initialized here. So I can have, let's say, get, and I can say return time taken. So this will give me, and I can set my time taken to be new value, whatever is available. So that's how you can kind of have getters and setters for your properties available over there. Let's go ahead and take this class and then create some objects out of it. So as I said, this is the blueprint, this is the actual object that I'm creating. So let's say I want to create fried rice object. So the recipe for this is just some space, can use default initializer, which is, can say fried rice. Time to cook this takes, it's around 30 minutes, and time taken already finished, I said 10 minutes since already in the process. Can give some values to it. I can also create more items, like for example I'll say using for the convenience method, can say lentil soup equal to recipe. I've not started making it, so I'm gonna say its name is lentil soup, and time to cook, let's say it takes 20 minutes to cook, and I don't have to provide how much time it taken because it will take this time taken as 0 since I've not yet started cooking, and it can keep on giving me values. I can print some values out. So for example, I can say fried rice dot, let's say time remaining to cook. Since it says 30 minutes and 10, so 30 minus 10, so it should give me 20, and that's what I get here. So this is how you can use your classes. This is the basic representation of a class with all the different things that you can do with classes. We can look at more on class methods and how to subclass in future, but this is a basic representation of a class, a blueprint, as well as a couple of objects that we have created using that particular class. Now that we know what classes are, or just recap, classes are nothing but blueprints from which you kind of create your objects, or classes are just like any recipe from which you can actually cook food and then have some real food objects in front of you. So let's look at class functions or class methods. What are different methods or how to code that? These are functionalities that can be added to your classes and will only exist inside your classes, which the objects which are created from the classes can use. For example, let's go to our previous code that we have written, and if you see there's no functions inside here, I'm going to add a couple of functions here. So I can just say func, I can say cook for is a function, and it will be passed. I'll have some minutes available. Say how much minutes do you want to cook this item for, and I can increase the, let's say, self.time taken plus equal to minutes. So I'm incrementing the time that was passed to me and take the time taken, and whatever time was passed to me, I increment the classes or objects time taken by that many minutes. Another thing I can write is what's the name of this dish, and I can just say that this is a function that provides me a string object pack. I can just get the name from here, but this is just another way of doing it. So I can just say self.name, and this will pass me back the name of the dish that I'm looking for. So let's go ahead and modify some more things here. So I'm going to remove this print statement, and now I can say more like time remaining to cook. Let's say I can say fried rice. Let me close this so it's easier. Fried rice dot, I can say what's the name of the dish. So time remaining to cook fried rice is, or I can just say colon and say fried rice dot I can say time remaining to cook. So this will tell me, this is kind of going to print me time remaining to cook. It's going to call this function, get the name fried rice is 20 minutes. Why? Because I say time 30 minutes and already have taken 10 minutes, so left is 20 minutes, and that's what I get back. Now I can say, go ahead and say fried rice dot cook for another 10 minutes. So this will call that function, cook fried rice for 10 more minutes, and print the same thing here. And if you see, after calling this function, it will update that and tell me that cook fried rice is 10 more minutes. So you can use functions to kind of make sure that you update some objects, or do some calculations or math on the objects that you're working on. So that's what class functions are. And next we'll probably look at subclasses, which will help you create more customized classes from existing objects. So I guess you understood what function, how to write functions, or what to do with the functions in a particular class. Swift subclasses. So now that we have seen how to use classes, how to write functions inside the classes, the next thing that we have is subclasses. Now subclasses is an idea where you already have a class defined which does everything that you need to do, and you want to kind of add some more functionality or create a class that has something more to it and can't be added to the existing class. For example, if I have a blueprint that is already been built for most of the things that it already does, and I want to add some extra things. For example, I can give you automobile. Let's go for a change. If I have a car class, the car class says that it can drive, it has 4 wheels, it has 2 doors. Now if I want to make a sports car, it does everything that the car does. Why do I have to define all those things again? So instead of that, I can just use that and then kind of add more functionality to the new blueprint that I'm building. Or you can take again food examples. You have a class or recipe which can get you cook rice. Now there can be two different subclasses to it. One is a steamed rice, one is fried rice. The only difference between that is how do you what additional things that you do in your new class, which is steamed rice, where you steam the rice, whereas in fried rice you take the existing rice that is cooked and fried. So that's additional functionality or a new blueprint that you create based on the existing blueprint that is there. So that's what subclasses does. And let's look at how we can start with subclasses and also then see how we can override some methods inside a subclass. So I'm going to start with the project that we already have created, the recipe project, and I'm going to go inside here. I'm going to get rid of this thing which will cause me a bunch of problem. So as soon as I add this, it will say that, okay, first of all I need that int, and then my default initializer is missing that particular max spice level, and I can set that to int, or I can just say spice level. You can say self dot spice level equal to spice level. See where else, and here also can give a default value, but probably go this dot spice level is int. You can say spice level is spice level provided. Once that is done, when I create here, I'll have to probably pass the spice level. Let's say this is fried rice, spice level is, let's say it's a 3, and here I can say spice level is more of a 2. This lentil soup is not that spicy, and we have everything working perfectly fine. Now I'm going to create another class here. I'm going to call it spicy recipe. Now recipe. So now if I want to create a recipe which is spicy recipe, which is same as the recipe, all I have to do is I can say it does everything that the normal recipe does. The only thing is it has one more parameter, which is type of pepper that I'm using. What pepper do I use in this particular recipe? That one doesn't have it because it's just a universal recipe for everything. Again, the problem is need an initializer, so I can create an initializer with all the parameters that the previous function needs. The only thing that changes is it also needs type of pepper, since it's not initialized, and just say string, so it's not initialized, so I'll have to provide that. And here, I'm not overriding, just initializing. Now here again, same thing. The only thing that I need to change here is type of pepper equal to the type of pepper that is passed. Rest of the stuff I can just call the super, which means the super class for spicy recipes recipe. So I'm going to call this method which already associates everything over there. So I can just say super initialize. I have the name, I have time to cook, I think I'm missing, let me see, time to cook and time to cook, time taken, and spice level. So I think I picked the wrong one, so I can just say time taken, and spice level is spice level provided to me. So this is how you can kind of create a new class, subclass from the existing class and give its initializer to it. Now I can update this cook for method here. I can also say, so if I say function cook for, and say it does exactly same, but let's say this one time taken plus equal to minutes, whatever is passed plus 5, whatever is passed plus extra 5 is what I would want to add to this. Now if you see here, when I do this, it says, oh, you are overriding a class that is already function that is already available over there. So all I have to do is say override function. So that means whenever a spicy recipe object is calling cook for, it was going to call this function and not the one above. So if I make a new object, let's say if I make what should I do, what should I come up with, something spicy. Let's see, how about jalapeno poppers. It's filled with hot cheese and it's jalapeno. So I'm going to say this is of the type spicy recipe, and let's give it all its objects. Just copy paste it here. Jalapeno poppers, and time to cook, say 20 minutes. Time taken 0. Spice level, I'll bump it up all the way to 5, and type of pepper is, say, jalapeno. Now when I use something similar here, let's say time to cook, jalapeno peppers, what is the name of the dish, time remaining to cook. So if you see, it uses all the functionality that the parent class already provides. Now if I say jalapeno poppers dot cook for, let's say 5 minutes, and to this, now if you see here, I said cook for 5 minutes and initially it says 20 minutes. So if I've added 5, where the extra 5 came from? Because it called this function, and that's why it shows 10. If I remove this function from here, it will call the parent function, and you'll see the change in a minute. And if you see, it says 15. So when you override something, it's gonna ignore the previous function and take this one, not the parents but the current object's classes function, and use that instead of the previous one. So that's how subclassing and overriding methods kind of helps you write some specific code to a new class that you defined, or a new recipe in this case defined. So that's how subclassing works. Okay. Basic structs. Structs are very similar to classes as per the syntax and functionality go, but the only difference is structs are passed by value and not passed by reference like classes, which means when you pass a structure to someone and they modify, the value of the actual struct doesn't get modified. So structs are used for simple instances, whereas classes are used for complex instances. Structures are well suited for when instances don't need inheritance or reference capabilities. So you can think of classes as a buffet where every person can go and pick their food, where whatever they do impacts the buffet, whereas structs are more likely like ordering from the menu and everyone has their own item even if they order the same item. So that's how I can think of classes and structs. Also, structs come with the default initializers, and you don't have to create initializers like in classes what we did. You can still create initializers if you want, but it sets the basic stuff for you. If you want to do something more in the initializer, then it's a good idea to create your initializers in structs. Let's go ahead and cook some structs. So see, let's open Xcode and let's start with the blank project. And I'm gonna kind of create a struct with the same name, recipe, and this struct has variable name, and this is of this type string. I have another one which is description, and I can have something similar to what we had in classes, where I can say time to cook, the type int, and we can give it value right here, return 30. So you can actually initialize something using this kind of fashion, or you can directly give value to it, assign some value to it. Now let's go ahead and use this. Create my food item equal to recipe, and if you see, I had not created an initializer, but when I say recipe, it will give me this value, so it automatically creates it. So I can say spicy cheese sandwich. What is it? It is a sandwich which with cheese and spicy Tabasco sauce. That's what this contains. I can look at it. I can say my food dot time to cook. It's gonna give me the same value that I've assigned here. And after, so if you see 30 minutes is how much times to cook this particular one. I can give the name, and that's how kind of structs work. It's much simpler. You don't have to do initializers or anything, but the only thing that you have to remember is it's passed by value. So when you pass this to someone else, they can do modifications and nothing will happen to the actual object that you have in hand. So whatever is passed as a different, it's just like other basic defaults types or primitive types where it's all passed by value. Struct methods. Now it's similar to class methods, but so you can add your own classes, but there's something catching about this thing where since you're passing the value, there is a catch about the structure being mutated or being changed. So to take care of some items when you're working with struct methods. So let's go and look at our existing example that we created for struct, where we created a recipe with one object here, which is my food, and then we kind of added this. Now let's add a function to this. Now whenever I add a function to my structure, let's say I want to change the description of this object, and I have to pass the new description, which is a string. So since I'm changing a particular parameter, for example in this case I'm changing the description to the new description, it's going to give me an error as soon as I save it, saying that you cannot assign a property to self which is immutable. So since a structure is passed by values immutable in nature, so it can't change. So what you have to do is to specifically say that it's a mutating function, so it will kind of change the value of your particular structure. So this is how you can kind of take over changing parameters or changing the variables inside a particular structure. Now I can go here, can just say my food dot change description not so spicy sandwich. And now when I look at my food dot description before and after, you'll see it let me change it. If I remove this, it will probably not even compile, because it's going to give me an error saying that you're trying to change something that is part of the structure and you're trying to modify it. So this is something that you have to be very careful about and use it very carefully. Unless it needs changing, you don't have to change it. Also consider using classes in this case if you have to, but that's an option that you have to remember about, and we're going to use this quite a lot in future. So that's about using methods in structs. Basic enumerations. Swift enumerations are nothing but related values put together into a group that you can then use instead of defining them again and again in different places in your application. So an enumeration is a user-defined data type which consists of, like, such a set of related values. That's what it has. Keywords in enum is used to define enumerated data type. So whenever we specify that we want to say enumeration, so we probably start with enum and then name, just like how we did with struct and classes. We said class. So similarly, we use enum here when to specify to the compiler that we are going to create a enum. Enumerations in Swift 4 also resembles the structure similar to that of C and Objective-C. It is declared in a class and its values are accessed through the instance of that class. Initial member value is defined using enum initializers. Its functionality is also extended by ensuring standard protocol functionality. So Swift 4 enumerations does not assign its members default value like C and Objective-C. Instead, the members are explicitly defined by their enumeration names. So an enumeration name should always start with a capital letter. That's something that you have to take care of. And there's different types of enumerations or the values that you pass. But let's start with the basic enumeration first and see how we can kind of create a basic enumeration and work with the enumeration in a particular class. So let's start this project with a basic enumeration. So I'm going to start enum project and remove everything, and I'm going to say that I'm going to use a enumeration. That's how you start with enumeration. And let's say I am looking for cuisine, and this different cuisines that I have is, my Xcode just crashed. Let's open it again. Okay, it's opening up. So different ones that we have is, let's say American, and want a few more, 1 2 3, let's try with 4. Say Thai, say Chinese, and say Indian. These are different cuisines that I have right now in my restaurant, let's say. And then can have something different. I can also have different types of meals that I provide, and I can shorthand it. Instead of writing in different lines, I can always say breakfast, comma, lunch, comma, dinner. So I can add everything together in one. I can also create, let's say, my food. The food that I'm interested is scene.chinese, and I can also say my food or my meal that I'm looking for is meal dot, let's say, lunch. You can print this out saying that you are having for this thing. So what is my food that I'm having? I'm having, according to this, it should be Chinese for my meal. So it should print out saying that you're having Chinese for lunch. So that's how enumerations work. So you can kind of define some values here and then keep on using them throughout your class or throughout your application, wherever you've defined it, and you don't have to kind of specifically add them for these things. So some things that kind of give an example is cuisine. If you're saying the days of the week, Monday, Tuesday, Wednesday, Thursday, Friday, there are a lot of different places where instead of having hard-coded values, you can kind of specify the cases and then come back to it for various reasons. So we'll look at some more different types of enums. Swift has made it more exciting by adding some different types of enums. So we'll probably look at them in a little while. Enumerations with associated values. Associated values can be different and don't have to be same, just like raw values that we saw before. So raw values have to be same, but associated values when in enumerations can be different. These have to be specified individually and can't be automatic like raw values. If you give one value as 1 and then the rest of them will follow 1 2 3 4 5, they'll automatically increment. Whereas in associated values, you have to specifically say what it is. They are not pre-populated and are created based on, like, let's say, constant or value that you provide, and varies when declared each time. So every time you declare it, it's gonna change. So let's look at one of the examples that I've created. So I'm gonna start from scratch, start a new project. I'm gonna call it enum raw. Start with, let's say, enum meals that I have, different meals of the day. So let's say for now, case breakfast is just a basic enum that I have. Case lunch, this one has a particular property which is of the type string. So I can say what are you serving me for lunch. Next one is dinner. I can specify what time is the dinner, and it's of the type end. So if you see, these are 3 different types. One is doesn't have anything that is passed along with it. The second one is string and end. Now this looks funny, but when you use it, that's where you'll see the idea of it. For example, let's say I can say my meal equal to meals dot breakfast. So I don't have to provide anything since it's just breakfast. And how do you use it? So you use it usually with a switch case, and I can specify that I'm looking for my meal, which is this one, and the different patterns that I have is breakfast. I can give a default, but I'm just gonna specify what I have. So I have 3 of them. I'm gonna take care of all 3 of them: lunch and dinner. So that's how you kind of say it. But let's say, since nothing has to be passed with it, I can just say print, and inside this, as I'll say, it's time to eat the most important meal of the day. So that's what I'm going to say when breakfast is selected, which is, in this case, that's what is going to show up. For lunch and dinner, since they come with some attribute, so I can say let serve, which is a string. So what am I serving? I can say print, can say that you get to eat, sorry for that, serve for I can say lunch, or I can just use the value of my meal. That's another way of doing it, but I'm gonna just do that. And for dinner, usually let at time is what is passed to me, so I can use that. You can have more than one attributes here. You can specify 3-4 of them. You'll probably see it in future when I actually use these things. So you get to eat dinner at time, specify that. So since I've selected breakfast, it's going to display the first case here. If I say lunch, it will ask me what are you serving for lunch. So let's say I'm serving sushi for lunch, and it will say you get to eat sushi for lunch. If I specify dinner, say what time is the dinner, I can say it's 7 is when you have the dinner. It's going to take some time. Okay, there you go. You get to eat dinner at 7 o'clock. So that's how associated values works, and it's a very important tool, a very important tool that we can use while programming for setting up different things, especially when it comes to enumeration. So this is one of the most powerful tool that we have with enumerations, is the associated values that we can use for Swift programming. So that's it with enumerations. Swift protocols. Hello and welcome to Swift protocols. In object-oriented programming, a protocol, or sometimes also called as an interface, is a way for two different objects to communicate with each other. In a protocol or interface, you define methods and values which the objects which use them, or say objects that follow them, implement them, just so that they can communicate with each other. It's more like saying when you cook something, it's a protocol or a rule that you follow a particular recipe. You do not go and add spices to your ice cream, or say have cheese with watermelon, even though in some countries it's a delicacy. So protocols are a set of rules that you follow while using a set of objects that you need to communicate with each other. So they're just definitions of functions or values or variables. They do not do anything inside them. It's only the responsibility of the class or the structure that's using it to implement them. So let's go and start defining a protocol and see how actually we write a protocol. So I'm going to go and open Xcode and create a new playground and call it protocols. Delete everything in here. So protocol is started with protocol, the name suggests. I'm going to give it a name, let's say recipe. So my protocol is a recipe protocol. Inside this, as I mentioned, I can create some variables. So I'm going to give a name to the recipe, make it of the type string. There's something wrong here that I'm not gonna let you know, and there you go. So property in protocol must have explicit get or get and set. So a protocol, when you're defining variables inside it, you probably have to give minimum a getter. So I'm going to give a getter for this, so you can actually get the value of it, but you can't set the value of it. I'm going to give another one called as recipe description, set it as a string too, and this one give both get and set. That's it. And next, let's define one function, a basic function that says tell me about this recipe. Now I'm not going to give the implementation of this, just the functionality, and let's say this returns back a string. So if you see a protocol, I'm just defining the functions and variables. I'm not actually assigning anything to it. That's how far the protocol goes. You don't do anything away from it. So when two classes or two objects are talking to each other, they can implement this protocol in them, and just so that they can communicate through functions or to values, so they can talk to each other. So that's how protocols works. Protocol extension. So now we know how to create protocols. Next, if we want to provide some default functionality to protocols, we can extend the functionality by using extension. Also, sometimes I call it ready to eat recipes. Even though someone defined the recipe for you and you want someone else to follow it and provide it to you, that's ready to eat, or say extension. It's totally up to you if you want to use this extension or not. You can go ahead and create your own or just use this. So kind of a basic functionality. You can also override it with more functionalities that you want. We can see this in our example that we created. We just created a recipe protocol, And let's say if you want to, so if you see this, we didn't give any functionality to our function. But if you want to give like a base functionality to it, so if someone who's implementing this recipe needs to just print it out, something like that. So what I can do is I can just say extension. What am I extending? The recipe. And I am going to extend this function. So I'm giving a basic functionality to it. Inside this, I'll just, let's say, return the name of the recipe and the description of the recipe. So if you see here, I'm just giving a basic functionality or extending the protocol just so that it gives some kind of functionality to whoever is using it. If they want to override it and write their own, it's up to them, whoever is using it, but I kind of give a basic function. And that's what an extension is. Extension helps you write some base functionality to your protocols. So we created some protocols, and we also created one basic extension to a particular protocol. Now next is, how do you use this protocol? So let's start with, let's see how we can use protocols in structs. So that's what we'll do. Let's use whatever we have created previously in a struct and see how we can bring everything together. So I'm going to go back to our project that we created here, recipe and extension recipe that we created. Next, I'm going to create a structure, and I'm going to call this structure a dinner structure. Now in this particular dinner structure, if I want to use a particular recipe, which is this protocol, and just do this recipe. That's how you implement a particular protocol inside a struct. Now it says that there's some problem with it, because if it follows, if you see here, type dinner does not conform to the protocol. So you're saying that this guy is saying that dinner is not actually following recipe. So I can just go here and I say fix this, and if you see, it will create the variable name and description for me. Now since this functionality is available by the extension, you don't have to implement it, and you can directly go ahead and let's see how it looks like. Variable, I'm gonna say create a dinner structure. I'm gonna get this, and I'm gonna provide some basic name. So let's say, let's try fried rice. Let's give it some description. What is a fried rice? Very good question. Now I say fried rice is a dish of cooked rice that has been, let's say, stir fried, hope so, in a wok or say frying pan. Something that I picked up from Wikipedia. You can say it whatever you want. You can add some ingredients to it if you want, such as eggs, vegetables, seafood, meat. It depends on who's eating it. Now next, I can just go ahead and say print dinner, no, not this, dinner dot, I want to call that function, tell me about this recipe. Even though I have not implemented that function here, you will see it prints it out because the extension provides that functionality, basic functionality to it. I can go ahead and take this functionality and override it in my structure. Say I love, let's say whatever it is, for dinner, which is this description, something like that. So if you see, as soon as I implemented this here, it kind of ignored this one. It says I love fried rice for dinner, which is, fried rice is a dish of, I mean, there's no need to go into details of this, but if you see, I kind of, when I implemented this function, it kind of overrode this, and you can have your own functionality. I can also get rid of this extension if I don't need, but if some other class or struct is using this, they can kind of use this basic terminology for it, and then if they want to override it, they are free to override it in this particular manner. So that's a little bit about protocols and how to use it and how to implement it. I hope it kind of helps you. Thanks. Swift generics. Swift provides generic features to write flexible and reusable types of functions. Generics are used to avoid duplicate implementation and also better abstraction. All the Swift standard libraries are built with generics code. arrays and dictionaries that we used before. These types belong to generic collections where arrays and dictionaries are defined to hold any type of values, be it int, double, string, or any kind of custom object, anything. Let's say in cooking, it's more like a process you follow but with different recipes. For example, you don't need a new kitchen to cook a different recipe. The same kitchen you work in can be used to cook anything, breakfast, lunch, or dinner. Think how difficult it would be if you have to use a new kitchen every time you have to cook something. And that's what we been used to do before generics came along. So that's what we used to do, which is bad. And now with generics, it helps us reduce that kind of functionality. So we write the function once and use it with any type. Let's look at some examples of how to create and use generics. So I'm going to start with the project in Xcode. Say new playground. Next, let's call it generics. Let's delete everything in here and start with the function to, let's say, swap some food. Now I can give an item 1. This is what we used to do before, so I'm not going to do anything that is more like generic version. I'll do it once. I'll show the bad version of it and then I'll show you the good version of it. So I'm going to give a string. So I'm going to kind of swap two items. Let's say item 1 with item 2, and item 2 is also a string. Now if I want to actually make sure that whatever is coming in is being modified, I can use inout. Inout means that modifying the local variable will also modify the passed in parameters. Without it, the passed in parameters will remain the same. So I'm going to change it here. So this is inout. Go. And inside here, let's just write a simple create a temp object, and I'll say this is item 1. Next, I'm going to say item 1 equal to item 2, and next one item 2 equal to temp. Pretty straightforward swapping mechanism here. If I want to do this, I can let's pass some values to it. Let me create a variable. I'm going to call it first course equal to, let's use fried rice. Second course, I can say more like lentil soup. That's how I like it. But let's say some people don't like it that way and they want to swap it. For example, let's print this out and see how it looks like. I'm gonna say first course and make sure this is outside second course. So I have both my courses, if you see, but some people don't like it that way, so they want their soup before the rice. So I can just say the first course and the second course. The and sign here is more like you're passing the enter object, the reference type, so I'm kind of giving a reference to that object, and there you go, it goes there. And if you see now, if I try to print this out, we first say fried rice and lentil, and then since it's swapped here, it's a lentil soup and fried rice. Now if I want to do the same thing for, let's say, something that is integer, so I can say function, let's give this name, I can say swap dinner and lunchtime. I don't know why I would want to do that, but let's say I do want a function that kind of takes in, I'm going to copy this here. Oops. I'm going to say time 1 and time 2. These are ints. Let's say whole numbers, not the doubles or anything. I'm just using entire numbers here. We use something similar. The swap mechanism works the same way. So this is time 1, time 1, time 1 is swapped by time 2, and time 2 is temp. So looks fine. Now next is, let's give it some values, just what we did before. Lunch, let's say, is at noon, and dinner is at around 7 p.m. Let's say that. So lunch and dinner Let's print this out and see how it looks like. Lunchtime, dinner time. There you go. Should show up lunch and dinner time. I want to swap it. Swap dinner and lunchtime. I'm gonna say swap lunch with dinner. Now when I print it, I'll have lunch and dinner swapped. So this is how it works. Now you have to write the function 2 times, once for strings to swap and then ints to swap. Now instead of this, if there was one function that would do both of them, so that's where generics comes into picture. To give start generics, I'll probably say swap, let's say 2 items, and when you create generic, you have to provide these angular bracket, and inside this you provide t, which tells it that you're going to provide something in your arguments, which can be anything that you want, or can be any type. So here I'm going to say, so same functionality goes here, can insert this here, and instead of string I can say t and t. That's the value type that it takes. So it's not a string or an int or double. It can be anything that you provide here, and it will swap those 2 items. The values are pretty much same. So it will take item 1, temp, item 2, and it will swap these. Now I don't need this function. I can first course, second course, I'm going to say swap 2 items, and you'll see what happens here is, after note that I've commented out, it takes a few seconds. If you see, it worked perfectly. Now will this work for numbers? Let's try it. I'm going to comment this out, and I'm going to say swap 2 items. Item 1 is lunch and dinner, and after a few seconds you'll see it works. So you write one single function instead of 2 different functions, and it takes any type of values and it will swap it. So every time you're kind of writing the same type of logic for different data types, you can always use generics, which makes your life much more easier. That's it for generics. Hello again. Now let's talk about different access levels that are available in Swift. One of the 4 fundamentals of object-oriented programming is encapsulation, and access control is part of it. Access control is also known as data hiding. It ensures data access to a class or an interface based on the control used. In object-oriented programming, access control is typically implemented using access modifiers in the object or the class. Although access modifiers may be syntactically different in different languages, they all attempt to achieve the same goal: define which variables and methods are visible and to whom. That's what it does. 3 different access levels are provided by Swift programming language. They are public, internal, and private. Again, to compare this, in my kitchen, everything I use in my kitchen is private to me and no one else can access it. A grocery store is a public place and anyone can come inside and buy whatever they want, and it's accessible to them. Whereas internal is more like a dorm room kitchen, where there might be items shared between different people who live in that dorm room, whereas not available to everyone outside that dorm room. So it's only available to that particular set of people who live in that particular house, and not available for people from outside. So that's more like an internal. So again, in short, or in technical terms, public allows use from any source file in the defining module and is not restricted to the module. You can access it from outside and inside that module. Internal allows use from any source file in the defining module, but not from outside that module. This is generally the default access level. Private allows use only from the enclosing declaration and to any extensions of that declaration, as long as it's in the same source file. Make sense? Okay, let's go and see how we can actually set up some access levels to this. We've been probably doing this before, but this is more of a exercise. So let's go ahead and start a new playground. Call it access level. Delete everything here. Now when you create a class, let's say I have a class called as chicken biscuit. Okay, that's one class. I'll show you how to use it on classes and variables and things. So I have another class, let's call it hash browns. I have one more class called as onion rings. Let's create some variables and see how these access levels can be used for variables. How many biscuits can I eat? How many do you think? Let's say 100. I'll say let's create a constant. See, how do you, am I hungry now? After looking at all these names, yes I am. Let's create a function. So I'll also show you how to use it on a function. Say, since I'm hungry, go eat some food. Okay, so I have classes, variables, constants, functions here. All you have to do is whenever you want to give an access level, I can just say this is public class, which is available to everyone in the module, in the entire project. Anyone can access it. If I want this only to be accessible inside the particular module, I can just say internal, not available to everyone. And this one, let's say private. This is available to only the particular class that is a module that is defining it, not to everyone else. Similarly for these guys, I can give it public. Let's use all the three different one. Internal let, so it's only available inside. Private. So it's pretty straightforward. You don't have to do much to kind of, but you have to make sure that you give the right access to the right variables, functions, classes, just so that none of them are used outside or can be, exploited in a different way. So make sure that you use these access levels properly depending on what you're working on. That's it. Access control for functions. I hope you have a good idea about how access controls or say access modifiers are used, which we learned in the previous videos. Now let's look at in more detail of how we can use them for functions. I know I showed you how to use that in a particular function, but it was an empty function. So let's create a proper function and then see how it works as let's call it a make function and then make it private. So I'll go back to my Xcode. I'm going to go and create a new playground. The shortcut for that was Command Alt Shift and N. I'm going to call this guy access control for functions. Let's delete everything here. I'm going to create a function called as, let's say, how many calories did I burn today? I'm going to give it some, let's say, from exercise, pretty much nothing, type of int, and say cooking. If you don't know, when you cook you kind of burn some calories, it's a lot of work. Coding, how much did I code? That's my basic function that I have. Let's say exercise, based on all the things that I've done, exercise is exercise plus cooking, it takes a lot of work, and coding, that also kind of takes out some calories from you. Next I'm gonna say, let's see, cooking. Let's make it a little fun. Cooking is kind of part of exercise plus cooking that I did, but no contribution from coding, just to make a functionality out of it. Similarly for coding, I'll say it's whatever exercise you did minus cooking, which wore you out more, so you're not able to code properly, plus whatever coding you did. Say that, just some made up values. Now just made up algorithm by me. I'm gonna print out all these three things: exercise, cooking, and coding. So this is my entire application. So no errors, no warnings. Now let's kind of call this function here. So I'm going to say 200 calories, 100 calories here, and 20 calories here. Let's try one more. Give a bunch of options. 400 calories, 80 cooking, and coding 100. One more. Calories 300, 200, and 400. So there you go. So it should print out all the values. Now this is a functionality that I have, but I don't want anyone else to use outside this particular module. Only this module should be able to use it, because I don't want anyone else to know what I'm doing with this particular function. So kind of to make it private, if I want it available to everyone, I can just say public. If I want it available only for the modules, I can say internal. And if I want only for this particular one, I'm gonna say it's private. So that's how you can use your access modifiers, access controls for your functions. That's it. Thank you. Access control for enumerations. Let's look here at how access modifiers can be used with enumerations. We've done that for functions before. We saw how to use for multiple various variables method, but we never kind of came across with enumerations. It's nothing different, it's almost same, but let's take an example and see how we can use the same thing for enumerations. Let's go back and create a project, playground, call it access control enums. Here, delete all the files, delete everything that is there. I'm going to create an enum called as a food enum, and inside this you can create one case which is name case, string type, case reviews, and this kind of gives me for this food what is the name of the food and how many reviews did it get. Let's say I have how many of 0 star or 1 star, 2 star, 3 star, 4 star and 5 stars. How many reviews did it get for each of those particular numbers. I'm going to create a food name. I'm going to call it food dot name. I'm going to give it a name, let's say veggie delight, and this particular food has reviews. Let's say food dot reviews, it got 1 star, 10 of 2 stars, 38 of 3 stars, 48 of 4 stars and 29 5 stars. That's what it got, the veggie delight option. I'm going to create a switch case here, switch, and value I'm going to say food name based on the food name. Pattern I can use dot name, and when I say let food name the value for it, and I can just say print food name. Let's fix this. Food name is slash, take the food name here, food name dot, and so I'm not going to add a default case. I'm going to take one more, and this one will be for the reviews. I'm going to say let 1 star to give all the different stars there, 2, 3, 4 and 5. Let's make it a little bit bigger. 2 star, 3 star, 4 star and 5 star, and I'm gonna say here, okay, let 1 star, 2 star, thing looks fine, print reviews, say kind of create these actually I should just take this 2, 3, 4 and 5, so I can say 1 star, 2 star, 3 star, 4 star and 5 star. So all my reviews on my function is good, and if you see here, since I have selected switch food name, it's going to give me food name. If I say food reviews, based on that it will select the second case and it will give me what stars it has. Now in this particular case, if I want to make this enum available to everyone, outside this particular module, I can go ahead and say public. This is how you can use access controls with your enums by changing the functionality in here. If you just want a particular module, you want it to a module privately used, and that's how you can kind of set up your variables. In this case, if you see, since it's private or file public, you can't access it from outside, so I can just say public in this case, and that should work perfectly fine. So that's how enums work with access control. Access control for protocols. Now we know what access controls are, how to use them, but we've not looked at how to use them with protocols. Let's look at how access modifiers can be used with protocols, and let's start with an example. We worked with protocols before, now we probably have to create both of them. So I'm going to go here and create a new playground, and I'll call it access control protocols. Now protocols are something that we've defined before of how a particular protocol is used, and how other classes use it is just the definition of functionality that is there, whereas other classes or structs that use it implement that particular protocol, and then they have to implement the functionality. So I'm going to go here and create a protocol, and I'll call this protocol, let's create classes first instead of creating protocol and which will be using our protocol. So I'm going to call this protocol as French fries, and this protocol, this particular French fries class has, let's say, quantity object of how many French fries do I have, int. Next I'll say I'll initialize this with a quantity of int type, and inside here I'll say self dot quantity equal to whatever I got, quantity. So that's initialization. Next, let's create our protocol that this French fries object can use, because I can directly go ahead and start saying that let French let's create just fries is what we want just fries. I can say French fries is the class thing, and I'm gonna give a quantity, come on, fries, should use that first time itself, 20. I'm gonna create one more class just to make it more fun. I'm gonna create a class called as cheesy fries, another class. Now this cheesy fries can be a subclass of, let's say, French fries, because it's just cheese on top of French fries. Now inside this I can create my, let's say, variable number of cheese types. So let's say cheese types of how many types of cheese do you want inside your cheesy fries. Usually there's one, but I want to add more than one. I can initialize, now I want to initialize the quantity too, because that's part of my French fries. So I'm going to say, okay, please provide me a quantity for that, and number of cheese types as integer, which is our class here. And then I'm going to say self dot number of cheese types equal to I'll give it whatever was passed to me when it was created. And next, instead of getting the quantity, I can just say self dot, or sorry, the superclass dot init. I can say quantity is quantity. So this way it will use this one and use it. Now another thing is, let's say if I have a protocol, and this protocol is cheesy protocol. I don't know where I come up with these names, but let's say, and it has an initializer method here. It's the protocol, so I don't want to implement this method. I'm going to just say that the parameters that it has is quantity, and that quantity is of type int, let's say. and I'm gonna say this cheesy fries is gonna follow that cheesy protocol, thing like that. Here now it says do you want to add the protocol value? So if it comes it as a required, because this is a protocol, so you'll have to add this particular thing. Now I'm going to make sure that this required you can probably have to do is, because I have a similar method in the parent one, so what I'm going to do is just implement it below here, and I'm going to say required override because the parent has it. I'm going to say this is a convenience method, and inside here I'm going to say self.init. I'm going to give it a quantity. Okay, I think I got the wrong method. Let me try. Okay, there you go. And here I can say whatever quantity was passed to me, and number of cheese is number of, I'll just say 0 here because I don't want to pass it anything. So there you go. So we have this method implemented. Since it's calling the parent method, so it requires only one parameter for the convenient method. I can't give the second one. It will be taken from this particular method here. So before we had just fries. Now let's go ahead and create our awesome fries. Of course, with cheese it automatically becomes awesome. Let's say cheesy fries, and I'll have to give quantity. I'll say I want, since it's awesome, let's not increase number of cheese. I want 5 different types of cheese on it. Now I can go ahead and print all these things. Let's just to see how it looks like. Let's say fries that I have is just fries. What I have, let's create 3 of them. How many cheesy fries do I have? Fries do I have is awesome fries dot quantity, right? And the last one is how many different types of cheese we have in there. You can say awesome fries dot number of cheese types, and there you go. Let's look at it. So if you see, even though we have provided 0 here, it took 5 because it has those number of fries over there. Now my just fries didn't print out properly. Let's try this one more time here. Fries, French fries. Where is our French fries? Quantity is 20. We provided a quantity of 20 here, and we initialized that particular variable. Now I'm going to go ahead and make sure that this works. French fries, we provided quantity int, provided that. Sometimes Xcode just, let me restart this Xcode. Or if I look at it again, I see that I'm just printing just fries. I'm not printing the quantity, and there you go. That should probably fix it, and it showed me 20 fries, cheesy fries 30, different types of cheese is 5. That's perfect. And now if I want to make my, let's say, protocol as public, or I can go here and just give it a public access modifier. I can call it private, that's only available to a particular class, or I can give it internal, which is available only to that particular module, internal modules of that project. So that's how you can give access modifiers to your protocols. And thank you. Access control for generics. Let's look at how we can use access controls for access modifiers for generics. We did generics in the last section, and let's look at how we can make sure that generics too are available throughout the project, or just the module, or outside the module. So let's go ahead and create a new project in Xcode. Let's start a new playground and call it access modifiers for generics. In here, delete everything. I'm going to start with the structure. Let's say I have a buffet, and it can take any variables inside it. Inside this, I can add a, let's say, what food items I'm gonna have inside it is equal to an array of whatever is passed to this buffet. That's what I have. And then I have a function to serve the food item T. It's my first function. I'm gonna say food items, whatever the food items is, dot append, and the element that I have is whatever is passed to me, food. Next, I have a function to remove food items from the buffet, and that will give me back an object that was removed. I'm gonna say, now here it's gonna give me a problem because I have to make sure to make it a mutating object. Now remove, I'm gonna say return, since I'm returning an object, I'm gonna say food items dot remove the last one that I've added. That's it. So that will give me back the last item that was added. Same thing here, I have to make sure this is mutating. Okay, so I have that ready. So I have my structure ready. Let's start with creating objects. I'm going to say lunch buffet is what I'm going to create. I'm going to say it's a buffet of all string objects. Okay, so that's what I'm going to add something to my not forget lunch buffet equal to or let's say dot serve. I want to serve a food. Let's say I want to serve, this is something that happens with a playground if you add both the quotes yourself. I'm going to serve guac for it, or it's a guacamole is what I'm going to serve. Can print my buffet and see what exactly it has. Lunch buffet dot food, okay, food items. So I can print this, and I can probably see here as soon as it says that there's no error. There you go, I have guacamole inside. But I can add more things to it. I'm gonna add a few more. I'm gonna add something, let's say green beans. I can add lasagna. I can add a dessert, let's say cake, to my buffet, and I have all my items available. So there you go. You see in the print console that is there in the debug console. Let's remove something. Let's remove cake. I don't want to have too much food in my buffet, so I can just say lunch buffet dot remove. I can say print. Let's see what's inside there. Should probably remove the last item, and you probably should also see remove cake should give you cake, because it's gonna remove it and return it back, that object. That's why you see here. And if you see in my buffet, the cake is been removed. Now how do I give give access control for generics? Now in here I can just say this is public and available to everyone, just like anything else. Public, private, can just specify the access modifier over there. Now if you see here, since it's private, you can't actually use it. So I'm going to create public, and it will be available to use any way you want. So that's how access modifiers work for generics. Hope you enjoyed this course. Thank you.